Good morning, Dr. G. A. Rathy, madam. Welcome and thanks for accepting our invitation. Myself, Dr. Umadevi, working as Associate Professor in the Computer Science Department. I'll be introducing you. Uh, Dear participants, Dr. G. Rathy, madam, is working as a professor in the Department of Electrical and Electronics Engineering, NITTR, Chennai, since 1998. Our area of specialization is power electronics and drives, and she has organized more than 250 faculty development programs for technical teachers of southern region of India. Apart from core engineering, she has expertise in the areas of curriculum development and curriculum evaluation. She designed, developed, and evaluated the power electronics engineering curriculum using criterion referenced test and revised Bloom's taxonomy. She effectively contributed as a resource person in more than 15 international overseas teachers courses and organized more than 7 international overseas teachers courses. Particularly, she educated the overseas trainees in the areas of skill development in electronics and curriculum evaluation using various evaluation tools and guided nearly 30 research and development project work in the area of curriculum evaluation for overseas teachers. She specially designed skill-oriented programs for electrical engineering disciplines such as PLC, SCADA, power electronics, PCB design, industrial automation, and electrical CAD, IoT, and electric vehicle engineering. She developed power electronics and special missions lab, industrial automation lab, and electrical simulation lab. She has published more than 28 articles in national and international journal and conferences. She has published a book on LabVIEW programming concepts with examples in SciTech publications in 2015. She successfully completed 4 MHRD sponsored projects worth rupees 30 lakh on modernize the department infrastructure. She has organized ATL, ISTs, and sponsored I-end workshops in the latest core areas. She is motivated towards the curriculum evaluation of various engineering curriculum with the latest pedagogical methods. She is now involved in setting up of skill-oriented industry-inclined laboratories. She has a vast experience in area of laboratory setting up and design. I think we will be hearing very nicely from Dr. Rathy madam. And thank you, Dr. Rathy madam. It is over to you.
Thank you, ma'am, for the opportunity. And so today you'll be listening and to the topics that which may be out of my experience in NITTR, which I am going to share with you regarding teaching, learning process, revised Bloom's taxonomy, how far it is very important that teachers should know all these topics. And finally, we'll be ending up with laboratory evaluation. And maybe I thought I can also tell you about open-ended experiments, which is now coming up in a which is gaining momentum. So how to give the lab questions so that the participants really get some skill out of that. So this will be our plan for this today's sessions. Maybe I think I can present my screen now.
Madam, your screen is visible and audible, and you can go ahead, madam.
Okay, ma'am. Maybe this slide screens are slides.
Slideshow you should do.
Madam. I have to put slideshow. Okay, ma'am.
Madam, first session is 10 to 11:30, no?
Okay, ma'am. Okay. I will distribute it accordingly, ma'am. 10 to 11:30, then 12 to 1:30.
Yes.
And after that, it is 2:30 to 4.
Yes, madam. Yes.
Okay, ma'am. Okay. Yeah. Okay. Yes, ma'am. I think now it is okay. Perfect.
Yeah.
Okay. So the first session, we will look into teaching learning process for innovative pedagogy. Okay. So as teachers, we should we should have the skill of delivering the classroom content. Okay, so the art and science of teaching is what we call as pedagogy. As teachers, we should know about this pedagogy. And this course, I heard from Dr. Abhishek that it is innovative pedagogy. Okay, so we normally have courses like IDDS, instructional design and delivery systems, then advanced pedagogy, now heutagogy. So all these courses are organized by our education department of NITTR Chennai. So this innovative pedagogy is a very right topic that has been selected for this. Maybe I don't know whether it is a 1 week program or a 2 week program, and you are learning more about the content development. And also, I am sure that you would have covered all the basic topics related to pedagogy, like lesson plan, student evaluation, and so on. Okay. So now my session is going to focus on the teaching learning process. So we call it, it is not just teaching and learning, it is a teaching learning process, because it involves, because you're going to deliver the content to so many adolescent students who will be highly motivated to learn, or who will be in a hyper state to learn. So you have to deliver it in such a way, in a creative manner, so that it reaches the students. So this is a very complicated process, the teaching learning process. So we'll have to focus more towards that, so that our final objective is the learning outcome. So whether we are able to achieve the outcome, the desired outcome of the teaching learning process. Okay. So NITTR, maybe I can give a few, uh, yeah, a brief introduction about NITTR Chennai. So NITTR Chennai, it is an autonomous body under Ministry of Education, catering to the needs of technical education. So we are TOTs, trainer of trainers, because teachers attend our training programs. We have both engineering departments and also education, media. So all other departments are also there, management, psychology. And we focus mainly on faculty development programs, which is now called as professional development programs. It is not only faculty. Anyone who is interested to develop the professional career can attend our training programs. And also we do IDDS, instructional design and delivery, for the newly recruited teachers. We do the curriculum development for the states, and also consultancy services. And all the four NITTRs together, we are offering a Swayam MOOC course for teacher education. And our short vision statement is, okay, this will be there only, I think so. Can I close this? Our short vision statement is promoting excellence in technical education. And this year we are entering into our 60th year of serving the southern states and developing the technical education in the southern states. So the agenda of this session is, we will look into the teaching process, the learning process, combined teaching learning process, and we have different learning styles. Similarly, as teachers also, we have different teaching styles. Okay, now we are going to focus on learning styles, the laws of learning, finally Bloom's taxonomy, where we look into the revised Bloom's taxonomy, the various levels and examples. So this will be our first session. So pedagogy. Pedagogy is the art and science of teaching. So everyone will not master this art of teaching. Okay. When we are doing this teaching in our colleges, we complete our engineering degree, and then we do this teaching, where we don't have any idea about this, how to teach and how you should deliver your content, how to prepare the lesson plan. But this courses on pedagogy will really help us to understand how we should teach, and what is the methodology you have to follow, so that the teaching reaches the student. Okay. So this pedagogy is very important for teachers. It's the art and science of teaching, the instruction in teaching methods, the art or method of teaching, that is pedagogy. And teaching, effective teaching. So we all do teaching, but we will not be able to know whether our teaching is effective or not. So you have various methods in which you can assess so whether your teaching is effective or not. So first, let us look into teaching. Effective teaching is one that will bring about, underline this, intended learning outcome. So you want your students to master a particular skill at the end of the class. If they are able to master the skill, that is your intended learning outcome, and you have achieved your objective, and your outcome is achieved. Okay. So effective teaching is one that we cannot assure this for each and every student, as our class size of the classroom is very big. So we have a common methodology of giving some assessment, some tutorial, or some other means. We will see what are the active learning strategies also that are available. So effective teaching is one that assures that you have a intended learning outcome. And to achieve this, you have to create a situation, creating a situation or selecting lifelike situation to enhance learning. So our normal classroom situation, so it is like maybe now we are moving towards learner-centered classrooms, learner-centered activities. Earlier, it was the teacher-centered, where the teacher will be giving lecture and it is only the students' activity to note down. As we all know, the attention span is very less. So within a short span, the students will get deviated. So we have to create a situation or selecting a lifelike situation to enhance learning. And your teaching should be showing, it should have contain, or it should have showing, telling, giving instructions, and making someone understand in order to learn. So that is also very much possible now because of the internet. So you can always show some models, you can give instructions, you can show animations, you can ask them to work with simulations so that they can understand. So that is why if you see the present generation students, they start doing simulations right from the beginning of the first year, and they understand the concepts. So they are able to explain well the concepts when compared to the previous, maybe the generations. Imparting knowledge and skills required to master a subject matter. So in teaching, these are the points you have to highlight. You have to make sure that you achieve the intended learning outcome. You create a situation where you are always enhancing learning. You make it like you show, you tell, you give instruction, you ask them to do some activity in the classroom in order to learn, and you impart knowledge and skills. So you may give a very good knowledge, but when you ask them to do it, it should not be they should hesitate. They should immediately do it. That is the practice we have to give them. So that I'll be explaining while talking about laboratory, how they should master in laboratory, imparting knowledge and skills required to master a subject matter. So for this, the teacher should equip themselves with all these, and only when you have or when you possess all this, you will be able to give it to your students. You cannot give what you do not have. So first, teachers should equip themselves with this teaching skills so that they deliver the best to the student. So teaching is perceived as simulating, directing, guiding the learners, and evaluating the learning outcomes of teaching. So you're going to simulate, direct, and guide them how to learn. And after learning, you're going to evaluate the learning outcomes. So whether they have or whether the learning outcomes are achieved. So teaching involves live human interaction. So that is why it is complicated. Teaching involves live human interaction between a teacher and one or more learners. Okay, so there is an interaction going on lively in a classroom. So people may say that in the next generation, teachers are not required. No, but that is not at all possible. Always teachers, they serve as the lighthouse for the students. They guide them in all aspects. So teachers cannot be replaced by any other learning methodology because of this lively human interaction that takes place maybe during a semester or during a year. So the teachers guide the students in all ways. The teacher who teaches, teacher controls the learning, is a dispenser of knowledge, an ultimate authority, and a director of learning. So the role of teacher. So they take control of the entire situation. They are the dispenser of knowledge, the ultimate authority, and a director of learning. So they show the way in which the students should learn. Teacher's role is to give the learner the responsibility to learn. You have to kindle in them how they should learn, and you have to show them the way in which they can learn and they can master the subject. So the decision maker in the teaching learning process is the teacher. So the teacher makes the decision maybe after completing one unit of your maybe curriculum, the subject that you're teaching, you give an assessment. So in the assessment, you will be able to find how far the students are able to perform. So if you find that it is not satisfactory, now you are the decision maker. You can change the methodology in which you teach. You can put more of visuals, more of simulations, and then again you can check the second unit, how the students are able to follow. So it is always the teacher who is a decision maker in the teaching learning process, and the teacher can change the methodology according to the learners. Now, this is the teaching process where we normally plan. If you are given a time of say 50 minutes to teach, you will not just go like that and stand in a classroom. You just plan for that. What is the content that I have to deliver? So how will I deliver? So what are the introduction part? How will I motivate the students and how will I deliver the content? And finally, how will I summarize, conclude, and also give the scope for future learning? So everything is planned in an effective manner. For the 50 minutes, you plan and then you go to the classroom and you start implementing that. So normally implementation will not go as per plan, but you cannot say that. Sometimes you may have some disturbances. Otherwise, it will go as per the plan. And finally, at the end of the class, you can put some questions to evaluate the students, because these questions will help you to know where we are, how far our teaching has reached the students. Now, in the planning phase, you are planning for a say a 50-hour, 50-minute teaching. So the needs of the learner. First is the needs of the learner. The second one, the achievable goals and objectives to meet the needs. So you have to look into the requirement of the learner. Is this as per the curriculum? So to what depth I have to cover this? That you will be able to know from the general objectives and also the specific objectives that is there at the start of the unit or the particular maybe we have normally in our curriculum, we have 5 units. So the first unit will have its own general objectives and specific objectives. So like that we have for every unit. So you'll have to look into the needs of the learner, the achievable goals and objectives to meet the needs, selection of content to be taught. Is it as per the curriculum? Motivation to carry out the goal. So you have to motivate the students so that they also do the work that is assigned to them. Strategies that most fit to carry out the goals. It is not only the conventional test, tutorial, assignments. What are the other strategies you can carry out which most fit to carry out your goal? And finally, the evaluation process to measure the learning outcomes. So what are the evaluation process you are planning? It is also very important because we need to measure. So then only we will be knowing where we are. So the considerations while planning, you have to consider the learner. Okay. see the if you look into the curriculum, so certain colleges, autonomous colleges, autonomous institutions, will have a curriculum, and they also revise the curriculum. Very often they give the latest topics and so on. But when you take a, college which is in a very rural area, where it is not autonomous and they don't have much of the facilities, so the learners there will also be, we have to treat the learners there. We cannot compare the learner in a very rural area with the learner in a very urban area, maybe an IIT student and a normal engineering college student. So you will have to consider the learner. The level of learning of these learners must be taken into account when we go for teaching. The availability of the materials. So the what are the materials that are available for learning? So that also you'll have to look into it. Time requirement of particular activity. So you should very well look into the weightage that is assigned to the topic, and you have to cover the topic as per that requirement. So because it is the first unit and you have lot of time, you cannot spend double the time for that, and the fifth unit you cannot neglect. So the time requirement for each and every activity must be very clearly planned and adjusted. All the 5 units should be given equal importance. The strategy needed to achieve the objective. So your goal is, maybe at the end of the course, the students should be able to master the whatever objective that is specified in each unit. Then you will have to go towards that. How will you make them master those objectives? For that, what are the strategies that are required? So the strategies needed to achieve the objective, and finally the teacher. So maybe a teacher who is not at all familiar with the subject, if, anyway, they can also do it, but an experienced teacher will be better compared to a new teacher who is assigned the subject. But this new teacher can also be, everybody will not be an experience, so you can also get training. The effort that you have to put will be more. So these are the considerations while you are planning for uh, planning for the teaching learning process. The next phase, so you have planned very well, you are a very good teacher, you have planned very well, everything is done. Next comes the implementation. So implementation is nothing but putting it into action. Whatever you have done, your plan, everything is very good, you have to put it into action, the different activities, in order to achieve the objectives through the subject matter. Okay, so you are going to use different teaching styles and strategies. In the implementation phase, you are going to implement. Maybe here I can give an example. So we were organizing a training program for the technical people of the transformer company called Andrew. Andrew is a transformer company, and they were asking for a training program at NITTR Chennai, and we are organizing it. So the afternoon, the session was given to me, and I had to explain about the working principle of the motor. And while I was explaining, they were all feeling so bored because I was drawing the diagram, and I was telling about the how the flux interaction takes place and so on. They were not interested. Okay, so then I thought after the break this will not work out, and what I did is I took a animation package from the net, and it was a very good animation on explaining how the motor works. So when I showed this animation, I was able to see the faces brightened up. They were not able to understand the theory that I was talking to them after, that is a post-lunch session. So when I showed this animation, they were all very much interested, and they were even at the end of the session, they were able to they understood how to calculate the EM, that is the how to derive at the EMF equation, and they were all able to do that. So that was the interest they were showing when some visuals on how the actual working of the motor taking place was there. So you have to use different one. One is not working, you have to immediately change your teaching style and strategy so that it reaches the learners. To accomplish the plan, interaction of the teacher and the learner is important. So you have your accomplishment. To accomplish the plan of this teaching learning, you have to interact with your students. So at the end of the class, maybe I have a slide what you have to do at the end of the class. So you have to reflect on your teaching. Okay, you have to reflect on your teaching according to De Bono, what he has told. I will just show the slide at the end of the class. So you have to always interact with the students. So you may ask me that if I keep on interacting with my students, how will I complete my syllabus? The answer will be there in the learning pyramid. Okay. Now this is the evaluation phase, where we only when you do the evaluation, you will know that whether the teaching learning process has taken place and whether the learning outcome is achieved. Okay. So you have the objectives. Objectives are maybe, for example, I'm going to in this class, maybe for example, I'm giving, I need to explain the working principle of a diode, and at the end of the session the student will be able to understand the working principle of a diode, and then he will be able to explain that. That is my objective, and I have started implementing that objective. I'm drawing the diagram of a diode, I am forward biasing, I am making it working, and I'm drawing the characteristics of a diode. Okay, everything is done fine. Now after the implementation, whether the objective is matching. Now I am asking them to draw the VI characteristics of the diode, and if a student is able to do that, then you match it with your objective. So is it matching? The learning outcome is matching with the objective. Then you will be, when you evaluate that, you will be able to find out whether the learning is achieved or learning outcome is satisfied. Okay. If it is achieved, we say that it is successfully achieved. Okay. So you do the evaluation where you match with the objective that is specified and the learning outcome that is achieved. So the difference between the two will let you know what is the learning that has taken place. So this is a continuous process. This was a diagram which I said in the teaching phase, you will be planning, implementing, and then evaluating. Okay. Feedback and reflection. Reflection is the process embedded in teaching where the teacher inquires into his action and provides deep and critical thinking. You should also reflect on your teaching. Feedback, it is the feedback that you get from the students, or maybe from the people who are attending the class. So those who are giving those feedback, that will help us to improve our plan also, how to plan for the class. A good teaching is well planned and activities are interrelated. See, because as you know that activity based learning is gaining momentum, you should not give any activity in your classroom. That activity should be related to your subject. So well planned and activities are interrelated. Okay, interrelated. Providing learning experiences or situation that will ensure understanding, application, and critical thinking of the theory or theories of learning. So you have to provide them. Normally we say, what is a college doing? See, a student is entering into the first year. He just comes to the class, he writes the exam, goes to the next year. And finally, at the end of the fourth year, he is graduating. So the learning experience is provided by the college. You just provide them the learning experience or a situation that will ensure understanding, application, and critical thinking. You are developing all these things. You give various topics for them to understand. You ask them to apply and work on it. And you also develop the critical thinking based on the theories of learning, where the learner is stimulated to think a reason. So he should always find out what is, he should be able to map or relate between the theory that he is studying here and the practical application in the industry. Utilizes prior learning and its application to new situation. He's learning one situation here, the same, he should be able to expand it to the other situations or new situations that are arising. So he should be able to apply that. Governed by democratic principles, embeds a sound evaluation process. Evaluation process is always very important in evaluating so that we actually know how far the learning has taken place. Now, normally in principles of teaching, so when teaching in a classroom, okay, you have to follow some of the principles of teaching. The first thing is principle of using the previous knowledge. So what is the entry level or entry behavior of the students? Maybe a student who has passed out of his 12th class. So you know what is the entry level or what is the knowledge that he will have, the previous knowledge. So taking into account when he is coming to the college, the first year when he is undergoing the physics subject, taking into account his previous knowledge, you have to start teaching in the first year. Principles of defining specific objectives of the lesson. Maybe today, as I gave an example of working of a diode, if that is your specific objective, you have to define that. At the end of the session, the student will be able to understand the working of the diode. That is the specific objective of the particular class or a particular lesson. So principle of defining specific objectives of the lesson and the principle of proceeding from simple to complex. So you would have seen in the nursery school students where they are first asked to do only addition. And after that, once they master addition, then they go to subtraction and finally multiplication and then division. So you move from simple to complex. Similarly, while teaching the class, in teaching in the class also, you'll have to move from simple to complex. You start with Ohm's law and then you go on with Kirchhoff's law and also the other theorems. Principle of proceeding from concrete to abstract. So concrete is what we see, what we are able to feel, what we are able to look into. Something is concrete is available. To abstract, what you have to imagine. So here, for example, if you want to teach the component resistor, so resistor all will be able to see. You can even show a resistor in the classroom and you can show it to the students. This is a resistor. Now, when you want to teach it, you can say an analogy of just you have there is a wide road and suddenly it is narrowing down and you have to pass through a bridge. Now what will happen? All the traffic will get crowded there. The same way resistor, it provides an obstruction to the flow of current. It is like a narrow bridge where all the electrons will come and start to squeeze in, so there is a drop. So what the students, the analogy that you give is something what they know in a day-to-day life. And this concrete is something like what they are able to see in the day-to-day life. And from there, you are moving to something which is imaginary, which we are not able to see. You can always proceed from concrete to abstract. And also, as I said, analogy is another way which will very much help in teaching. Principle of proceeding from general to specific. See, when you give such analogies, even when the student forgets the other thing, they will be able to remember the analogy and they will be able to write it. So principle of proceeding from general to specific. So general, you can quote a general rule and then you can come to specific examples. Okay, so first you can proceed from general to specific, and also we have from specific to general. Both ways it is there, that we will see in the later slide. Principle of proceeding from known to unknown. So maybe in the 12th standard, they would have studied about semiconductors. So that is known to them. So from there you take over. So how you are making a diode, the P-type semiconductor, N-type semiconductor. So from known, you move from known to unknown. So these are some of the principles of teaching. You should not use the technical jargons which the students cannot understand. Okay. So you have to always make them feel that it is very simple. So this is what you have learned. Now just an advancement. That is what we are going to learn in this class. So that is how you'll have to motivate them. Now the content sequencing should also be like from known to unknown. The content in a curriculum, if you take, the content sequencing should also be done in such a way that you move from known to unknown simple to complex, concrete to abstract. So that is how the content should also be sequenced. So in content sequencing, as I showed in the principles of teaching, from general you can move to specific. From specific you can also move to a general. That is from rules to examples, and also from examples to rules. So from rule to example, general to specific, or from rule to examples, we call it as deductive. We call it as deductive. And when specific example or activity is given and then a rule is quoted, that is called inductive. So it can be either a deductive or inductive. For example, here first I am going to quote a rule. I'm going to give the Ohm's law. Okay, or Kirchhoff's law, or any law. I'm just explaining the laws. So when you are explaining the laws, it should be in such a way that you repeat it twice or thrice until it gets into the memory of the students, the rote learning. Okay, so you repeat it. So first you quote the rule and then you quote the example, maybe Ohm's law, and now you ask them to find out what will be the, I have a lamp connected. This is the power supply that is given, and maybe assume a resistance of so much in the circuit. What will be the current that is flowing? Now you are asking them to calculate it to a specific activity. So first you have given them uh, the rule or the law, and then you are asking them to apply it and do some activity. So that is deductive. Instead of now first giving the rule, you just say that, yes, I want to do the domestic wiring of my house, where I have a load of this much. And here I have to find how much current will be flowing in the circuit. So you give some activity. Okay, you give some activity, and there you give the formula and ask them to calculate the current. And after that, you say, this is very much applicable, or this is very much, or this falls under the category of this law. Okay, so from the example, you can move to the rule, that is called inductive. So either it can be deductive or inductive. Analogy to reality. As I said, you can always teach with analogy to reality. And in explaining all the concepts, you can use this. This is a very good way of explaining to the students. And also you can take the example of various bio-inspired, maybe we have like the bullet train. So how the nose of the bullet train is designed. It is from the diving of the kingfisher, how it's diving into water. So like that, we have various bio-inspired examples which you can quote. I still remember the faculty was taking a class on wind energy systems, where he was telling about the blade, and wherever you cut the blade, it will have the shape of a aerofoil. So this aerofoil shape minimizes the resistance, and he was comparing the blade to the wings of a bird. So the analogy, so that when you give that analogy, that will remain in the minds of the students. So you can always relate with analogies. So normally here we say that the current flowing, it is like similar to water flowing, because you cannot see the current, but however you can see the water that is flowing through the pipeline. So you can always relate that the current flowing in a circuit is equal to, or the analogy is like a water flowing through a pipeline. Now, using of teaching strategies, learning is an active process, or you can say it's a dynamic process. It's not a static one. So it should change accordingly. According to the topic that you are going to deliver, you have to change your methodology. And these teachers and the teachers have to actively engage the learners in learning activity if the teacher wants the students to learn what they intend to teach. So if I want my student to learn what I am intended to teach, then I have to follow the strategies that will be interesting. The more senses that are involved in learning, the better, the more and better the learning. So what are the senses? Audio, then your auditory, your visual, and all these, if you are the more the senses you are using, the more better is the learning. So maybe we had a program, training program, which was conducted by the Dudley College from UK. Okay, so they did a leadership program, and it was called the UKRI program. I think most of you would have even heard about, and some of you would have even attended the program. UKRI, it was an AICTE MHRD initiative program, UKRI. So those teachers from the Dudley College, when they came over here, they said that the classroom setup itself should be changed. They wanted the round table, and they wanted the students to sit in groups. It's not like facing the teacher, it is within them sitting in groups. And every 10 minutes, a question will be given to the group. Even a small, that is, can you define the term management? So you'll have to discuss and you have to give a suitable answer. One person should make it, and even they had a board where you can, magnetic board where you can go and put your paper there. What is that you have written, and you can explain. So like every 10 minutes, you will have some activity that is related to that classroom, the particular classroom content that is being taught. So the more the activity, you will not feel how the time is, because it was a 3 hour session. And normally if you say, oh, 3 hours, how I'm going to sit, but that was full of activity, where at the end of the third hour, oh, already 3 hours has passed. You will not be able to know how this 3 hours has passed. So if you have more activity, then that will help the students to learn more, and also more senses are involved in learning, that will make learning better. So we say that in pedagogy, the educational process is characterized by its cyclic nature, where we have phase one is teaching, phase two is peer learning, and phase three is learning. So once again, you teach, they learn, peer learning is there, learning is there. So this peer learning also, if you see in the learning pyramid, it has got more weightage. Now we will, of all the slides that I've seen, which was all focusing on teacher, teaching, teaching strategy. Now finally, we are going to define teaching. So how will you define teaching? Maybe in science, if you want to define a term, that will be a standard. If I ask what is density, you will all say it is mass by volume. Okay. Now, but when I ask, can you define teaching? Everybody will have your own definition, because it is social science. So based on all the uh, theories, concepts, examples taking into consideration, you can arrive at a final decision on how you will define teaching. So same, there is a definition here for teaching. Teaching is defined as interactive process. Without interaction, teaching will not happen. Interactive process, primarily involving classroom talk, which takes place between the teacher and student. So it is the talk that is taking place between the teacher and the student, occurring during certain definable activity. Okay. So it is an interactive process, and it is a talk between the teacher and the student, which occurs. When is it? It is always that you're talking? No. Under certain definable activity, that is during your classroom teaching. So we can define teaching in this way. Now let us move on to learning. So learning, I can give an example for learning. Okay. A small boy is learning how to ride a bicycle. Ride a bicycle. So first, what he will do, he needs to balance the bicycle. So he will hold the handlebar, and he will try to uh, push the cycle. Then he will slightly get onto the pedal, and he will start moving in the front. Then he will put both his legs on the pedal, and after that, over the handlebar, he will put his leg. And finally, he will be able to ride the bicycle. Now, once he has learnt the skill of riding the bicycle, after that, when you give a bicycle to him, will he do all these process? Like first pushing the bicycle, then standing on the pedal, then uh, putting his leg on the other side on both the pedal, then over the, no. Now it is, he's just going to put his leg over the handlebar, sit on the seat, and he's going to start riding the bicycle. Now there is a permanent change, relatively permanent change in his behavior. After that, he's not going to follow all these process. It's only that he's going to sit on the seat and ride the bicycle. So there is a relatively permanent change in his behavior. And that is what we call as learning. He has learned the skill of riding the bicycle. Okay. So a change in an individual's behavior caused by experience or self activity. So he has learned again and again, and also by on his own, he has learned the skill of riding the bicycle. So this change that is brought or brought in an individual, you call that as learning. So it's a relatively permanent change in behavior. This implies that learning can only happen through the individual's activity or his own doing. So even if you push them to that extent, unless they are not motivated to carry out, nothing will happen. So learning happens only through individual's activity or his own doing. It can be intentional or unintentional. So somebody would have fallen in the water and they would have started then uh, learning swimming. So unintentional. Somebody would have gone for the swimming class and they would have properly mastered the art of swimming. So it can be either intentional or unintentional. Now there are two principal types of learning process. One we call as the behavioral learning theory, and the other one is the cognitive learning theory. Two principal types of learning process. One is the behavioral learning theory, and the other is the cognitive learning theory. So the behavioral learning theory, it emphasizes observable behavior such as new skills, KSA, okay, knowledge, skill, and attitude, which can be demonstrated. So you learn something and then you are able to do it. You observe so that you have the or you get the enough knowledge, attitude, and skill which can be demonstrated, because this has to be, it should be observable and measurable. If the individual has changed his behavior, then he has learned. Then he has learned the particular, that is the behavioral theory. So as I said, the behavior of the boy changes when you give the cycle, when he has learned the skill of riding the bicycle. So that is a change in behavior, which we call that as the behavioral learning theory. The next one is the cognitive learning theory. So cognitive is, you know, it is related with the brain, cognitive. So this is concerned with human learning in which unobservable mental process are used to learn and remember new information or acquired skill related to concept of meaningful learning through cognitive models. So you are able to learn that. So it is related to your human brain, cognitive. There it is behavioral. This is cognitive. Okay. So it is concerned with the brain, related to the brain, and how you are able to remember the new information and the acquired skill. So you have discovery learning, reception learning, and also the events of learning by Robert Gagne. So discovery learning was proposed by Jerome Bruner, reception learning by David Osbel, and events of learning by Robert Gagne. Now, first, let us look into discovery learning that was proposed by Jerome Bruner. Okay. So, discovery learning. So some individuals, if you see, they will be very much curious to learn to do. So they want to do everything and learn on their own. So this discovery learning states that individuals learn from his own discovery of the environment. So the learners are very curious. Thus, they can be self motivated until they find answers to the problem. This gave rise to emerging theory of constructivism and self learning. So learning is flexible, exploratory, and independent. So you can see some of the students who will be very much, they want to do, they want to learn, very hyperactive in the classroom. So such they want to do it on their own and they want to learn. They are very curious, self motivated, and they want to find answers for the problem. So they will have the learning to be quite interesting, exploratory, and independent. They want to learn on their own. So such is the discovery learning which was proposed by Jerome Bruner. The reception learning. So though the learners are inherently curious, they may not be able to know what is important or relevant, and they need some external motivation. Here you can see the teacher is external motivation in order to learn. Okay, so both emphasizes that prior learning is important in order to learn new things, as knowledge is continuously changing once it is in the learner's mind. So for both, either for discovery learning or for reception learning, discovery, it is out of their own interest. They are highly motivated, they learn. Reception learning, though they are inherently curious, they need an external factor to just tell them what is right, what is wrong, how should move, and so on. So both emphasizes that prior learning is important in order to learn new things, as knowledge is continuously changing. So this reception learning was proposed by David Osbel. Okay, and events of learning, Robert Gagnes. This is the very famous theory about the events of learning. What are the events that will occur during the learning? So the first step is the motivation phase. So where you motivate the students. Normally the students will immediately ask you, what is the use of learning this? Maybe the Laplace transform, the Fourier transform in mathematics. So then you'll have to relate it. So in circuit theory, when you want to find what is the transition that takes place when you switch on the supply, you will be applying the Laplace transform. So like that, you would have to relate it. So this will motivate the students. The motivation phase, apprehending phase, acquisition phase, the retention, what they acquire, they have to retain it. Retention phase, then they have to recall it. Generalize, recalling phase, generalization phase, and finally the feedback phase. Okay. And the motivation phase, maybe I can give an example here. Maybe you are going to, your topic on that day is about special electrical machines, which is now very much used in electric vehicles, PMSM, and even in wind energy generators, we use PMSG. So those are all coming under the special electrical machine. So you're going to teach about special electrical machines. So you can just tell them the motivation phase. So when you learn about this particular machine, let us take PMSM, permanent magnet synchronous motor. So you can tell that nowadays, if you're going to work on electric vehicles, this motor is only used there, though other motors are there, but we are using PMSM in, you have other types of motors also, but particularly PMSM is used in EVs. So you have to tell them that if you learn this motor and when you're interested to work with electric vehicle, you should know about this, then only you will be able to work with electric vehicles. So that is the motivation. So if any student is very much willing to join the EV industry, then they will really be interested to learn, because that is going to be the target. Okay. So the motivation, you have motivated them. Then the apprehending, whatever KSA is required, you are going to add it, apprehending it to that apprehending. And acquisition, now you have apprehended that this should be acquired by the student, then only it is useful. So acquisition, is it really acquired by the student? Maybe some will remember, as the theory class is for 50 minutes, they will remember, but at the end of the class, they may forget everything. Are they able to retain it? Retention phase. Okay, retention. Are they able to retain the knowledge and the skill that has been delivered to them? Retention. Recall. Maybe the next day in the classroom, you are putting forth some questions regarding the permanent synchronous motor. Are the students able to explain? Recall and then explain. Generalization. The same way you can apply this principle to the other motor. Generalize. Are you able to generalize this? And finally, the feedback. So whether it was easy for you to follow or it was difficult for you to follow, whether you need some other strategy to explain the working principle construction of the motor. So like that, feedback you're giving. Based on the feedback, the teacher can change the strategy and this can start again. So these are the events of learning which was proposed by Robert Gagne. So, this theory is a very famous theory, events of learning. So learning based on the theory of learning. So learning, it's a social process where interaction with other learners and teachers are needed. So you need to interact with other learners and teachers. The result of individual experience and self-activity, learning, both it should be observable and measurable. It takes place when all senses are utilized, all our 5 senses are utilized, will be enhanced when learner is stimulated, directed, guided, and feedback is given immediately. Each learner, they have their own learning style. It's not that everyone will be in the same stage of learning. Everyone they have got their own learning style. So this is a summary of the learning process or the learning so far what we have discussed. Okay, now you can define learning. Learning is a relatively permanent change in behavior. Once learning has taken place, then they will not go back to the start and they will repeat all the process. It is a relatively permanent change in behavior resulting from reinforced practice. So you are practicing it again and again, and as a result of this reinforced practice, there is a permanent change in the behavior, which we call as learning. Okay. Maybe if you have had other sessions regarding maybe the teaching learning, where you would have got this is the I can say it's a universal definition of learning. It's a relatively permanent change in behavior. This term you have to remember. When there is a permanent change in behavior resulting from reinforced practice, you say that learning has taken place. So learning is a process through which a person acquires the new knowledge, skill, or attitude. So this is also the terminology which you'll always be hearing, KSA. So you should have the knowledge, the skill, and the attitude so that you are going to learn. So learning is a process through which the person acquires new knowledge, skill, and attitude. Now, moving on to the learning pyramid, as I was telling, that teachers think that it's only out of our teaching or learning happens, but that is not that. The answer is there in the learning pyramid. So there's a learning pyramid, and research shows that 75% retention rate in learning by doing. Only when you do, you will be having 75% of the retention of what you have learned. 90% retention rate in learning is by teaching others. So when I have to explain something to my peer group, I'll have to first understand the concept and then only I'll be able to explain that. So when I do that, 90% of retention is there. And if I do something, do an experiment, and then I start thinking over that or recalling that, I'll be able to have 75% retention rate. Now let us look into the learning pyramid. So this is the what we call as the learning pyramid. And normally as teachers, what we think. So when I give the lecture, the student will understand everything. Everything should go directly into his head. So, but that is not happening. So in the learning pyramid, you can see that the weightage that is given to lecture is only 5%. 5% is the weightage that is given to the lecture class. Now, if the student is reading on his own, so the weightage is 10%. 10% weightage is given for reading. If you show some audio visuals, the retention rate will be around 20%. They will remember. So in that slide that was there, and so they are able to retain that. If you show some demonstration, the retention is 30 percentage. If it is a group discussion, the retention rate is 50%, and where you have to read a lot and you have to prepare yourself for group discussions. If it is practiced by doing, your retention rate is 75%. 75% you will be able to retain what you have learned. Teaching others or the peer learning, it is 90%. So now you will be able to understand that in our schools in those days, when one student is doing well in the subject, the teachers will be attaching some slow learners also with the fast learner, so that this fast learner will be able to teach those slow learners and bring them to the level. So teaching others, that has got the highest weightage of 90%. So what has got the least weightage, that is the lecture. So as teachers, we can stop lecturing and we can give more of audio visual demonstration, other learning, active learning strategies can be added in our classroom to make the teaching learning process effective. Okay. Now there is a model called WARC model, which will really help the teacher to make the teaching process effective. So this WARC model is nothing but you have visual learners in your classroom who will learn by seeing. Auditory learners who learn by hearing, auditory. Read, write learners by reading and writing. And K, you have the kinesthetic learners, tactile. Okay, they learn by touching or learn by doing. So these types of learners are available in the classroom. Okay, so as a teacher, how will you proceed? Okay, so you have some visual learners, and these visual learners, they prefer to see the visuals. So their mantra is, when I see, then I understand. When I see, I understand. They prefer to see the information. They don't want you to show only the text or read only something. No, they prefer to see information in the form of pictures, diagrams, cartoons, demonstrations. Okay, picture words and concepts they hear as images. Whatever you say, it will all be brought in front of their eyes as images. Easily distracted in lecture with no visual aids. They'll not be interested in a lecture if there is no visual aids, and they'll be overwhelmed with intensive visuals accompanied by lecture. If they have so many visuals accompanied by lecture, they'll be really very happy and benefits from using charts, maps, notes, and flashcards when studying. So for this type of learners, you'll have to use visuals in your classroom. Maybe when you are using a PowerPoint, you can show some of the animations, or for future reference, you can show them some of the websites where they can go and they can look into the actual working of the apparatus devices. Maybe if it is a history subject, the charts, maps, and so on. Okay. So they will be looking into only what is the visual that is available in a presentation. Next comes the auditory, auditory learners. So these auditory learners, they prefer to hear information spoken. So they want to hear the information that is spoken. They can observe a lecture with little effort. So it will be like as though they are doing something, but they will be hearing, and they can observe a lecture with little effort, may not need careful notes to learn. Often I have heard people telling, just if I read once, my son will be, or son or my daughter will be able to immediately grasp that and give whatever or condense the information and give it in a short form, or they will be able to repeat in the same form. So they prefer to hear information spoken, can observe a lecture with little effort, may not need careful notes to learn, often avoid eye contact in order to concentrate. They will not be looking into the teacher, but they will be carefully taking down the notes. May read aloud to themselves. So you would have seen some of the students, they read aloud so that they don't get distracted and they learn quickly. So those learners are the auditory learners. So read, write. So these learners, they prefer to read, write information. Okay, they want to read and write. They can also observe a lecture with little effort, but they need careful notes to learn because the habit is writing. And they also often avoid eye contact in order to concentrate. And these learners are also of the habit, they read aloud to themselves. Writing will help them to remember and conceptualize. I had a friend of mine who used to always write and learn. Even when she's not having time, she will start writing. Then we used to ask her, see, how far will you write? Because in our PG, we need to, we had lot of portions to cover just by writing. But she said, see, you'll all be reading 5 times, but only one time I'm writing. That is enough for me to retain the content that I have learned. So 5 times reading is equal to 1 time writing. So that's what the explanation she will give. She is a writing learner, read, write learner, read, write. And in that way, she will learn. The other type is the kinesthetic learner or the kinesthetic learning. It's a learning style where we prefer only hands-on approach. Hands-on approach. You would have observed some of the students in the classroom. When it is a practical class, they will be very much interested. But when it is theory, they will be sitting so dull. Here, they want to learn everything by practicing or by doing it. So the kinesthetic learners prefer this physical interaction to say reading a textbook or watching a lecture. So they learn through active movement and experience. So they want to learn by doing, by touching things. Okay, so everything should be like touch and feel, and then you do it and you observe. Okay, so they are active learners where they want to do it and learn. They don't want to listen or they don't want to look into visuals. They want to practice everything, do it. So use of work, UK research says that 40% learners tend to be kinesthetic and tactile, 35% visual, and 25% are auditory learners. So in a classroom, you will have a mix of all these learners, kinesthetic and tactile, visual, and also auditory and read write learners. So a teacher, it's a responsibility to have some visuals. So not to disappoint the visual learner. Auditory, where the teacher is going to teach in the classroom, some activity that they can do and learn, and some assignments where they can write it. So if it is a mixture of all this, then whatever style the learner may have, they will have the interest in learning. And retention of learning is highest in kinesthetic and tactile, lowest in auditory. So when you do some activity, your retention of learning is good. And learners demonstrate all the three learning styles, but tend to be dominant in one. So though they demonstrate all the three, but they will be dominant in one, lose concentration and interest in the weaker ones. So the teachers should aim to develop the three learning styles in all the students. So this has been given by Brichno and Younger in 2004. Now the active learning. Now we are moving to the innovative pedagogy, where you have some of the innovative methods that you can use for learning. One such is active learning. One such strategy is active learning. So an active learning strategy is any type of activity during class. It can be a face-to-face, online, or outside the class that engages learners in deep thought about the subject matter in your course or in their course. Okay, so it can be any type of activity during the class. It can be a face-to-face or online or outside the class that provoke the thinking of the learners. So they think deep and they go deep into the subject matter and they learn about the course. So in active learning, the learners are clustered into small groups. As I said, how Dudley College has taught us about the management course. So they don't want as a whole class, they divide the students into groups. They are clustered into small groups to discuss a course or a topic, reflecting individually at the end of the class or the session. Now, you cannot give all the class, total class to them, but you can give few minutes to them. Maybe you are starting a new topic where you want to know what is the prerequisite knowledge that they possess. You can ask a question, you can ask them to discuss and then come back to you what is that they know about the particular topic. Working through an application problem with a partner before presenting to a larger class, or participating in class, group, or team discussion boards. So you discuss with a smaller group and then you come to the bigger group. In a class, you explain that. So that is an active learning where we have more strategies under this active learning. So one important activity that you would have heard is think, pair, share. So this is also an active learning strategy. So this think, pair, share, it is a collaborative teaching strategy first proposed by Frank Lehman of University of Maryland in 1891. So this TPS, think, pair, share, it is a collaborative learning strategy. Collaborative, all together you are learning, where students work together to solve a problem or answer a question about an assigned reading. This strategy requires students to think individually about a topic or answer to a question and share ideas with the classmates. So if you have a class, a group of people, you can ask the students to form some small groups and you give a problem. The students will discuss with them and they will come out with the answer and share the ideas to the classmates. So this is think, pair, share. Now I have an example for this think, pair, share, where the question is, write a program to find the factorial of a number. Write a program to find the factorial of a number. So in the think phase, individual activity is you write the code for the program. That is the think phase. Individually, you think and you write the code for the program. Then you pair, the pair phase. Group activity where n can vary from 2 to 3. Now you write the C++ code for the program and then share. share faces for the class. Compare your solution with that shown in the class. Underline the errors if any. So first you think, then you pair with the class among 2 or 3, discuss the code. Then you share the code in the class. So this is a active learning strategy or a collaborative learning strategy where you can form the students into small groups and you can give them some activity. So we have a lot of problems that we have to solve in the classroom. Maybe you can ask, sorry, a small group to do it, and then first think, then pair, and then share to the class. So the other active learning strategy is cooperative learning, where you can share with the students assignment or a project work. So now you'll have to do a lot of mini projects or any other project assignment or project you can share to the class. So examples, it can be like peer support, group work, role play, inquiry based, jigsaw method, think, pair, think, write, pair and share. So that also comes under this. All these are the active learning strategies, comes under the cooperative learning. Now, what are the benefits of giving them or dividing the students into groups in the classroom and then asking them to finish it? So it is like always they shouldn't be in the same group. That should also be shuffled so that fresh ideas come into the group. Communication skill development. When you share with ideas with the fellow colleagues or fellow students, your communication skill is getting developed. Conflict resolution skill development. So everybody will not be of the same idea. There will be various ideas. So the conflict resolution skill development. Then you have the leadership. You are going to present to the entire class. You have the leadership skill development, shared responsibility, interpersonal skill development, and students learn patience and cooperation. So this is what are the benefits of the active learning strategy, and this cooperative learning is also one under that. Okay. Peer instruction. Peer instruction also comes under this active learning strategy, which can be used for innovative pedagogy. So where you can again ask the students, peer discussion is going on. Okay, so you have the staff present there. So after that, they share the ideas, show the results, the class and discussion, and move forward or adjust. Okay, they move forward, and where they have the lecture, and then you have some questions. You move, analyze the result. Again, you start, share the idea, move forward, and so on. Okay, so this is peer discussion. It is all a form of active learning where you can help the students to actively participate and in the classroom, and in the same way result in some learning. Experiential learning. So experiential learning, it's also a process of learning by doing. So now more focus is on activity based active learning. Okay, experiential learning. So all these are only gaining momentum in innovative pedagogy. So experiential learning is the process of learning by doing, by engaging students in hands-on experience and reflection. They are better able to connect theories and knowledge learned in the classroom to real world situation. So that is what we do in our practicals. We have to bridge what is the theory that is learned, what is the practical that is done in the laboratory, and how do you relate it to the real world situation. Okay, so it is experiential learning is by doing. We have the laboratory experiments, internship, field activities, innovation exercises, active experimentation, practicums, undergraduate research activity like mini projects and so on. So all these will result in experiential learning. Now UNESCO has given the 4 pillars of learning. Okay, so they have said that there are 4 pillars of learning in the Delors report in 1996. Learning the treasure. Learning is, that is learning hyphen the treasure within. So they have said that there are 4 pillars of learning, where first one is learning to know. Why do you learn? Because you want to know something, you are learning to know. Next is learning to do. As you have learned to know, now you have to learn to do it. And the third one is learning to be. The fourth one is learning to live together. So these are the 4 pillars of learning as per UNESCO's Delors report. Okay. So in order to help modern society cope with the changes in the world around, so the Delors report has given this learning the treasure within, and it has recommended 4 pillars of learning. First one is learning to know, acquiring the instrument of understanding or learning how to learn. You should know how to learn. Say, I'm very much motivated, I want to learn, but I don't know how to learn, then effect is zero. So you should know how to learn also. Second one is learning how to do it. What you have learned, what you have understood, how to do. Apply the learned knowledge in daily life to be able to act creatively and responsibly in one's environment. Okay. Then learning to be, that is the third one. Acquiring universally shared values, developing self-knowledge, become immersed in one's own culture and wisdom. You learn to know, you learn to do, and you learn to be on your own. What is the self-knowledge that you have got? Becoming immersed in one's own culture and wisdom, learning to be on your own. And then it is not that it is enough if you learn to know, learn to do, learn to be, but you have to learn to live together. So promoting social cohesion and peaceful coexistence, being able to celebrate diversity in people and in their histories, traditions, beliefs, values, and cultures. So you have to learn to live in a society, living together in cohesion. So these are the 4 pillars. See, though you learn to know, to do, to be, but without living together, it is also not useful. So these are the 4 pillars of learning as per UNESCO's theory of learning. Maybe shall I stop here, and after that, shall we have a break, and then I will continue with the theories of learning.
Madam, this is Umadevi. Yes, madam, we can take a break and we will resume back by 12 p.m., madam.
12. Okay, ma'am.
Okay.
Okay.
Now 11:30, we'll have a break and then 12 p.m. we'll resume, madam.
Okay, okay, ma'am.
Thank you. And for this, in this session, you talked about planning, evaluation, teaching, active learning, and cooperative learning strategies. Further, we'll continue, madam, at 12
Okay,
p.m.
ma'am.
Thank you, madam.
Thank you. Thank you.
Yeah.
Yeah.
Rathy, madam, you can continue. Madam, we can see your screen, madam.
Okay, ma'am.
Slideshow.
Okay, ma'am. Yes, welcome back to the session. So in this session, we are going to discuss about the theories of learning. So all these learning has got some theories which we will discuss, and also then I will just because as we are talking about the teaching learning process, revise Bloom's taxonomy also plays a very important role in this teaching learning process. So how will you, maybe the curriculum that is given to you, how will you classify it based on revised Bloom's taxonomy, and based on that, how you can deliver the content in the class, that also you can determine. So we will look into the revised Bloom's taxonomy, and finally we'll have a quiz, okay, on menti.com, where you can answer. So this will be the plan for this session from 12 to maybe 1:30 or 1:20. So then afternoon we will move on to maybe I can focus a little bit on assessment, and then also on laboratory evaluation, or I can directly move on to laboratory evaluation also. Okay. So continuing on the theories of learning, what we have seen in the morning session, it is all about how do you look into the teaching. Okay, what are the teaching styles that are required in the present day scenario? Maybe the teaching strategies that a teacher should follow, so that the final outcome, it is the intended learning outcome, whether that has been reached or not. And then the learning, we have looked into the definition for learning, which is a relatively permanent change in behavior. We have seen the various learning strategies, the active learning strategies nowadays, as we have to follow that to have a very good involvement in the classroom. And you can also make the students discuss among themselves, so that finally you have a classroom which is very active. It is not like what the teacher says and what the students listen. It is more of task orientation in the classroom. Now let us move on to some of the, we have also looked into the SMART model, where we have the learning styles: visual, audio, read, light, and kinesthetic. And the learning pyramid, what is the weightage that is given to each activity, where we have also found that 90% of weightage is given to teaching others, or peer instruction or peer discussion, and 75 percentage is given for doing. And in experiential learning, where we say that by doing we learn more, so experiential learning can also be included in innovative pedagogy. Now let us look into the theories of learning, where we have the law of readiness, law of practice, and law of effect or reward. So these theories are based on a story, not a story, it is a real theory that was given by Thorndike's, this trial and error theory of learning. So this was, as you know, that any medicine or any method will be first trialed or practiced with some animals, and here Thorndike has used a cat. Okay, you can see the setup here. So he used a cat for his learning, the theory of learning, and he put this cat, it is a very hungry cat, and this cat is put inside a glass box, and the door is closed, but there is a switch at the bottom of the door, and if that switch is pressed, the door will open. And fish, the cat always likes fish, so a fish is also kept in a bowl outside the door. So this is the setup, and we can call it as an experimental setup. So this setup was given by Thorndike, and he started experimenting. So first is the law of readiness. So the law of readiness, it is that the cat is inside and the cat is hungry. Now the cat wants to come out and eat this fish. So the cat is willing or attempting, or it is ready to come out of this box. So the cat starts moving inside here and there. So it wants to find a way out. So that is the readiness for learning, or the readiness to come out. So that is there within the cat. So the cat starts moving inside the box here and there. Okay, the law of readiness. The second one is law of practice. Okay, so first, after starting to move inside the box here and there, By mistake, the cat presses the button that is there at the below the box. So now the door opens, the cat comes outside, it has got its reward. Okay. So this is by mistake. It was ready to come out, but it didn't have a practice. It just came out. By mistake, it has pressed the button. Now, second time, again, Thorndick now made the cat to sit inside the box. He closed the door and he kept a fish outside. So this time also, he didn't know that there is a button there. So again, it was moving inside fast here and there. Finally, by mistake, it stepped on the button, the door opened, and the cat came out and had the fish. So this continued for some 5 or 6 times. And after that, when the cat was put inside the box, it readily went there, it pressed the button, and it came out. This is the law of practice. The second law, that is the law of practice. So once you practice that, then now you are able to find out what is the technology or what is the nuance in that, how I can come out. I can just press the button so that I can come out. So first it was ready to come out of the box or the glass case. Second, it had enough practice so that it was able to come out. And what made the cat come out of the box? It was the reward or the law of effect, which is the fish that is there. It wanted this fish so badly that it tried and it came out. So in this way, the cat learned that there is a button there at the end of the box and it can come out of that. So this is a trial and error method because the cat was not able to find out initially that there is a button there. But in the way of learning, in the trial and error way of learning, it was ready to come out. And in the meanwhile, because of practice, it was able to find out the button. And as it is getting a reward, it was ready to learn that and come out of the box. So this is Thorndike's trial and error theory of learning. So this learning also, first we should have the readiness or the interest or the attitude to learn. And then it is the practice, not only with the readiness attitude. So once you have that, you will start practicing. So by practicing, you will be able to achieve mastery. And when you achieve mastery, you should be rewarded. This is the theory of learning. Okay, so this teaching and learning, if you see, it goes together. It cannot be separated. So one cannot succeed without the support and success of the other. So you can say that, okay, I'll be teaching. I don't mind whether my students learn or not. No, you cannot say that. Or students will say, oh, I can learn. I don't want a teacher to teach. No, that is also not possible. So one cannot succeed without the support and success of the other. Teaching styles of the teacher. So in teaching styles also, the teacher can be an authoritative teacher. So you have 4 styles of teaching. So this teaching style of the teacher should match with the learning style of the learner. Okay, so normally teachers are advised to have all the work model in the presentation so that they can match with the learning style. Similarly, the teaching styles also, you have the 4 teaching styles. So that should also, you can try to match with the learning style of the learners. The learner is the center of teaching. Without learner, there is no use in teaching. So he's a center of teaching, and knowledge of the learner and his learning styles should be considered. Learners become complex individuals capable of learning on their own. The repertoire of teaching should also increase. So teaching is the cause and learning is the effect. So normally, as we know, in every laws or in every theories, we have a cause and an effect. So as you know, in Newton's third law of motion, for every action, there is an equal and opposite reaction. So similarly here, teaching is the cause and learning is the effect. And learning in teaching and teaching for learning. So we have ways of teaching and learning. Different teaching methods and strategies can be clustered according to the number of the students to be or being taught. Okay. So if your classroom has got more than 80, so then you cannot use the strategy that you are using for a smaller group. You'll have to change it. So for a larger group teaching, lecture, panel discussion, seminar, forums, demonstration, combination of lecture and demo is very much effective. For a smaller group, you can have like role playing, bus sessions, workshop process approach, discovery learning, cooperative learning. So this is all possible with the smaller groups. For individualized teaching, modular instruction, e-teaching, programmed instructions, so they can practice, they can go to their system, they can practice for individualized teaching. Now the ways of teaching, we have the traditional methods. So inductive method, morning I was telling you about inductive method. You give an example and then go for the rule. That is inductive. Deductive, first tell the rule and then go for the example. Then you have the project method, laboratory method, question answer method, lecture method. So these are some of the traditional ways of teaching. And in improved ways of teaching, we have the integrative technique, discovery approach, process approach, conceptual mastery in learning, e-learning, simulation, case-based teaching. So all these cooperative teaching. So all these forms and falls under the improved teaching methods. So the ways of learning, we have seen the trial and error, Thorndike's related to stimulus conditioning, classical conditioning theory of Pavlov. Pavlov also said that, see, you can always have a stimulus and a response. So Pavlov did his study with the help of a dog. So Thorndike tried with the cat, what example I have told you. Similarly, Pavlov will be seeing in the afternoon for lab experiments, where he has trained a dog with certain stimulus and what is the response. The insight, higher level of intelligence is being utilized, and observation and imitation through modeling. You can observe and also imitate, which we all do for laboratory based exercises. So that is also the ways of learning. And teaching and learning in the curriculum, how the student should learn how to learn. Okay, teaching and learning gives life to the curriculum. So without teaching and learning your curriculum, because it is the implementation. So without teaching and learning, there is no meaning in your curriculum. Value placed in teaching will reap the same value in learning. And a good curriculum can be judged by the kind of teaching and the quality of learning derived from it. So if you have a very good curriculum, what is the strategies? So in a good curriculum, we'll have all these specified. What are the methodology you have to follow for teaching? So it is judged by the kind of teaching and the quality, because your evaluation pattern will also be given there, and how we are going to evaluate your students. Thereby, you will know the quality of learning that is derived from that. So this was what I was telling. Now, reflecting on your teaching. As teachers, we plan and we go, we implement, we evaluate, we do everything. But once you come out of the classroom, you have to reflect on your teaching. To evaluate your teaching at the end of the session, you may use the reflective tool called PNI. PNI formulated by Edward D. Bono. So what is this Edward D. Bono saying? He's saying that when you leave the classroom, you'll have to reflect on your teaching. How will you reflect? So you have to find that what is P, what worked positively, what did not turn out well, because we'll have so many derivations to do, and in some step you may have got stuck. What did not turn out well? So he has not mentioned the word as normally we don't mention it as negative. We say what did not work out well. Okay, so that also you'll have to look. What was interesting? What was interesting? Now, how should I change my class? Ideas for change. So in this way, at the end of every class, when you leave the class, you'll have to reflect on your teaching. So this is one technique in which you can make your teaching much more effective. So what went well, what didn't go well, what was very interesting to the students, and what are the ideas for change to make your teaching effective. Okay, so you can always reflect on this. And normally the criteria for good teaching, as we all know, that you should have a proper planning, should motivate the students. Normally we say in curriculum, you have lot of content. Okay, and most of them are nice to know content. It is nice to know, but you have to give them what is must to know content, what is must for them. Okay, nice to know content is not important, must to know content is important. So give the necessary information. Okay, give the necessary information that is required. The individual differences can be bridged. You be very sympathetic, cooperative, and create a democratic atmosphere. If somebody is asking a question, it shouldn't be the way that you have to threaten him and make him sit. No, because that is a doubt that he has got. So his question is very genuine, unique. You appreciate him and him or her and answer to the question. Progressive. So every class, let it be progressive. And if there's some remedial measure is required, you can also look into that. A good teaching style is dynamic and not rigid. So that you have to, maybe at the start of the semester, you would have followed some method. At the end, there will be a need for you to change your methodology of teaching, which you should always be prepared to do. And you have to guide the students to prepare for the future. So you have to give them the a list of materials that they can refer for the future reference. So the relationship of teaching and learning. So we have teaching, telling, showing, doing. And in learning, which is focusing on, morning we were looking only into the cognitive theory of learning. So you have the cognitive aspect, the psychomotor. That is what we are going to discuss in our laboratory session, psychomotor aspect, and also the affective domain. It is related to our heart. Affective, what we are interested. Cognitive is related to our brain. Psychomotor is related to the hands, and affective domain, which is related to the attitude. So the learning influences the three domains: the cognitive, affective, and also the psychomotor. Okay, so in teaching also you can address the cognitive, affective, and psychomotor. And the learning, so you can say that learning takes place when the theory from knowledge to application, you are able to receive and do. So here we will be discussing about the Bloom's taxonomy. What is that from the level? Maybe I'll be talking about the revised Bloom's taxonomy, where we have from remembering to applying the behavioral values. Okay, like attitude, interest, discipline, practicals, the performance. All this results in learning. So the learning domains, where we classify it as cognitive, affective, and psychomotor. Now, as a framework to support the teaching learning process, Bloom's taxonomy is most widely used and an enduring tool through which a teacher can think about the student's learning. So the cognitive domain, we are talking that we need to uh, take care of the knowledge that is delivered to the students. So this Bloom's taxonomy, it supports this teaching learning, and it can be considered as a very good tool through which a teacher can think about students' learning. So if you see this Bloom's taxonomy, this Bloom's taxonomy was originally created by the American educational psychologist Benjamin Bloom in 1956. And Bloom's taxonomy provides a hierarchical ordering of cognitive skills and is used worldwide to help inform successful teaching practice. So everywhere we are using Bloom's taxonomy to provide a hierarchical ordering of the cognitive skills, and it is used for successful teaching practice. For teachers, if you take Bloom's taxonomy, it's a practical tool to use, providing a framework in which to plan challenging lessons that help to ensure students' progress is maximized. a fundamental principle of successive teaching. So it is really a practical tool which provides a challenging lesson to know whether the student is progressing. And it's a fundamental principle of successful teaching. Now, Bloom's taxonomy also provides an excellent foundation for lessons as it can be used as a framework in which to deliver appropriate activities, assessment, questioning, objectives, and outcomes. So based on that, you will be classifying what are the appropriate activities, assessment you can give, the questioning, objectives, and outcomes. Now, this was introduced in 1956, and after that, his student, Bloom's student, students Anderson and Krathwohl, they published the revised Bloom's taxonomy in 2001, a revision of Bloom's taxonomy with the title A Taxonomy for Teaching, Learning, and Assessment. So what is the difference between the two? We have here in 1956, everything was given as a noun, like knowledge, comprehension, application, analysis, synthesis, and evaluation. But Anderson and Krathwohl said that you have to have it in a verb form: remembering, understanding, applying, analyzing, evaluating, and creating. Okay, so from the noun you're changing to verb form, and here these stages, remembering, understanding, applying, analyzing, are the same. And here the evaluation, the last stage evaluation, has come here in the 5th place. And above that, you should have some creativity, or creating is being introduced here in the Bloom's taxonomy. As you know, taxonomy is the level. You have the various levels through which you will be able to deliver the content. That is, in the remembering stage also you can give, where you can give some laws. Understanding, you can explain the theory behind that. You can apply it to a practical application, analyze the result, you can evaluate the result, and finally create a new application based on this. Okay, so this is the revised Bloom's taxonomy, which will serve as a foundation for the teaching learning process. Because in the teaching learning process, we have been given with the hyphenated content. Maybe unit 1 in a syllabus, you have the content. So for every content that is there, you will be writing the general objective and the specific objective. And under this general objective is, as the name specifies, it is general. Then you have the specific objective. And in specific objective, you can start from the level from remembering, understanding, applying. So normally in engineering, if you see, we go up to the level of applying and sometimes analyzing. Only when you ask them to do some projects, you are going to the level of creativity or creative. Okay. So in Bloom's taxonomy, we have level 1, that is remembering. Recall facts and basic concepts. Then understanding, explain ideas or concepts. Applying, use information in new situations to answer the questions or problems. Analyzing, take apart information to show relationship, causes, and connections. Evaluating, justify a stand or a position. And in creativity, or producing something. So you have the 6 levels. Okay, 6 levels where we move from remembering, understanding, applying, analyzing, evaluating, and creating. Now in level 1, if you see remembering. So remembering, it is the most basic requirement in the least amount of cognitive rigor. It's just remembering. Okay. So this is about students recalling the key information. Students recalling the key information. Maybe if I repeat, that is why they say normally when you are talking about, or when you are handling the session on any theories or laws, you'll have to repeat it thrice so that it is well received by the students. And after that, they will be able to recall the key information. Okay, recall. So under remembering, you can use these verbs. So you have the 6 levels, and for 6 levels, you have the verbs defining these levels. So you can use like arrange, define, list. And when you say this list, maybe define, I can say define Ohm's law. So it should not be combined with other define Ohm's law and Kirchhoff's law. No, because a student will be able to define Ohm's law, but not Kirchhoff's. It had to be given separate. Define Ohm's law. Now list. I should not say list all the applications of a diode. No. List 5 applications. Be specific. List 5 applications of a diode. Match. So you have 2 columns where you can match the name, order, recall, reproduce. So all these are level 1 verbs, which is mainly focusing on remembering. Level 2 is understanding of the facts remembered. Understanding. At this level 2, the student who recalls the definition of a word and would also be able to show understanding of the word by using it in a context. Okay, you're not only recalling that, but you can understand and explain that. So that is the next level, understanding the facts that are remembered. Okay, so now you can have these verbs in level 2, like discuss, explain, identify, summarize, report, classify. These are some of the verbs that fall into this level 2 category. Normally, see, when you are writing the general objective and after that the specific objective, so in each topic you will be going to what level you want, whether it is only understanding or you're going above that, applying. Okay, so if you are finishing it only with the understanding level, where they will be able to understand and understand or explain the operation of a particular device or so on. So that level is only understand. Okay, understanding. You're stopping there. You're explaining, discussing, summarizing. So these are the verbs that are used to indicate level 2. So moving on to level 3, applying. Applying is how students can take their knowledge and understanding. So first is remembering, that is the knowledge and understanding, and applying it to different situations. So you have gained some knowledge, you have understood the theory behind that, and now this should be applied to the various situations. This usually involves students answering questions or solving problems. So the verbs that are associated with level 3, you can have like applying, calculating, demonstrating, interpreting, showing, solving, suggesting. So all these are level 3 verbs of Bloom's taxonomy, that is the applying. Level 4 is analyzing. Analyzing is about students being able to draw connections between ideas, thinking critically to break down information into the sum of its parts. Maybe you have got a waveform. Now you can analyze the waveform. Without analyzing, you will not be able to know whether the particular output is right. So you have to analyze. Or any circuit is being built up. Now the circuit, you are not able to get the output. What went wrong? You analyze. So analyzing is about students being able to draw connections between ideas, thinking critically to break down information into some of its parts. So you are splitting it into parts and then you are analyzing, analyze, appraise, compare, contrast, distinguish, explore, infer, investigate. All these are verbs that are associated with level 4 analyzing. Okay. Now moving on to level 5. Level 5 is evaluating. Evaluating. So evaluating is reached when students can make accurate assessments or judgments about different concepts. So students can make inferences, find effective solutions to problem, and justify conclusions while drawing on their knowledge and understand. So evaluating, you are evaluating, you are assessing the students, you are judging, justifying. Okay, so you have the argue, assess, critique, defend, evaluate, judge, and justify. So these are the verbs that are associated with level 5, evaluating. And level 6, that is the final level, that is creating. Creating at this final level of Bloom's taxonomy, students demonstrate what they have learned by creating something new. You can see now most of the students are designing a e-vehicle for the project, designing a drone for the project with so much payload and so on. So they are using the technology that they have and the theory that they have learned right from second year, third year, and finally they are applying it in a project work. Okay, where they are able to create something new, either tangible or conceptual. For example, writing a report, creating a new computer program, revising a process to improve the results. So these are the verbs associated with level 6, where you can see that compose, create, construct, devise, generate, organize, plan, and produce. So these are the verbs associated with level 6 Bloom's taxonomy. Now, this following chart illustrates the level of thinking and expectation of the learner at each level of hierarchy. So, remembering, can the learner recall or remember the information? So, when you are taking a unit, you have to split it like this. You'll have to have few questions under remembering. See, we have seen the 3 domains like cognitive, affective, and psychomotor. So Bloom's taxonomy, revised Bloom's taxonomy is associated with this domain, cognitive domain. And when you are in a teaching learning process, so in the curriculum, you'll have to have certain questions related to remembering. So there you are going to test whether the learner can recall or remember the information. So the next step is understanding. Can the learner explain the ideas and the concepts? So you'll have to have a classification understanding where you can give the understand the working of motor, the working of the transformer. So all these working principles you can put or explain. So the verb will be explain or understand or describe. So all this you can use here in understanding. Can the learner explain the ideas and the concepts? Okay, that is the second level. Applying. Can the learner use the information in a new way? You have to apply it to a situation where you can use it in a new way. Can the learner differentiate between the various parts or components? Analyze. Evaluate. Can the learner justify a position or decision? And finally, creating. Can the learner create a new product? So now you have patents for various products and various other technologies. So can the learner create new products, new ideas, or new patents, new technology? Okay, so here also you will be able to see that as Bloom's taxonomy is a hierarchy of progressive process, you will be moving from simple to complex. So which is our teaching principle. And also you will be moving from concrete to abstract. Okay, from concrete to abstract. So the simple way is remembering, and then final complex way is creating. First, master those lower down of the pyramid, and then master the higher up. The higher ups, the framework promotes what Bloom termed as mastery. See, remembering is just a very simple task. If you ask the student about a certain remembering, list 5 applications of of power electronics or of thyristor, something you can ask like that. So they will be able to tell, then understand. Okay, applying. All these are lower levels, and analyzing, evaluating, and creating will be the higher levels. So when they achieve higher level, we say that they have achieved the mastery learning. So that is the master of the subject. Okay, mastery. So moving up the taxonomy, the student becomes more knowledgeable and skilled and develop improved understanding of the content that they are learning as you move to analyzing, evaluating, and creating. Using the verbs, teachers can align with different levels of taxonomy and create lesson plan, task, and also question paper setting. So based on these verbs, you can align with these verbs and how it is useful for teachers. The teachers can create the lesson plan, the task, and also they can do the question paper settings. Now I can give you some examples. Now based on that, you can also do some exercises. So example one is remembering, where it is like recite Newton's 3 laws of motion. So this is to check whether they are able to recall the 3 laws of motion. So in the second phase, it is understanding, or the second level, it is understanding. Explain Newton's 3 laws of motion. Now you just explain. First, it is only recite. Now you explain Newton's 3 laws of motion. Applying. You are applying it to a project where you are saying calculate the kinetic energy of a projectile. So the projectile is moving in a particular path. Can you calculate the kinetic energy of the projectile by understanding the Newton's 3 laws of motion? Analyzing. Differentiate between the potential and the kinetic energy. So you analyze what is kinetic energy, what is potential energy. So differentiate between the two. Evaluating. Determine whether using conservation of energy or conservation of momentum would be more appropriate for solving a dynamic problem. Okay. And finally, creating. Design an original homework problem dealing with the principle of conservation of energy. So this is one example showing the various 6 levels where you can start with reciting the 3 laws of motion and go up to designing or design an original, take original problem and do it with the conservation of energy. Now example 2 is with electronics, where you can teach the students how to build a rectifier circuit. So the first one, in the remembering level, you can draw the symbol of a diode and mark it the terminals. So it's a very easy one where you can do it. Explain the working of the diode. It is level 2 understanding. Using diodes, rig up this rectifier circuit. Now you are applying what you have learned in level 1 and level 2. You are applying it in level 3. Analyze the circuit. Maybe if the circuit is not working, or if you are getting an output, even then whether the output is right, you analyze the circuit. Calculate the performance parameters of the circuit. So once the circuit is there, what is the efficiency of the particular circuit, and also you calculate the output, input efficiency, form factor, power factor, so many other factor, transformer utilization factor. So all these performance parameters you can calculate. At the pinnacle of Bloom's taxonomy, students have to build a rectifier circuit with a filter circuit. So in the 6th level, now they have to design a rectifier circuit, build a rectifier circuit with filter, and verify the result that it is giving. So that will give a level of, now they have designed their own rectifier circuit. So it is, to some level you can say it is creativity, but you have so many rectifier, but for a student of that maybe the 2nd year or 3rd semester, to build up a circuit will be somewhat creative. Now example 3, to teach students how to build a web page. Okay. So the first one is about an example of HTML script and how it translates into a web page. That is the level 1. Remembering. Okay. So the different parts of HTML script, that is understanding. To begin building their own basic web page, requiring them to solve any problem in their script, that is level 3. Okay. Applying what you have learned here. Now you are applying to build your own basic web page. Investigating the additional features that could be added to the web page, that is level 4, analyzing. Okay. Then assessing its strength and how it could be improved, level 5, that is evaluating. And at the highest level, to create something completely new or original, producing a website that fulfills a particular purpose, that is level 6. So why these examples are given to you? Now what you can do is, you can take a subject that you are teaching, and you can take a first unit in that subject, where you can find out, maybe you can write the general objective and the specific objective, and then you can take a topic, maybe a particular topic, and you can say, I can start from the remembering level, I can go up to the level of creating. So these examples, you can do it as an exercise and you can submit it. Maybe I don't know whether you have done this exercise. Maybe if not, you can also practice this, so that when you are teaching in the classroom, you can start from the level of remembering and you can go up to the level of creating. So this will be very much useful while assessing the students in question paper setting. So all this, what are the levels that you have given? And in one more useful advantage of this is, maybe a new teacher is teaching a subject and an experienced teacher is teaching a subject. So the new teacher will be will not be going into depth of the content. Maybe they try to finish it. For example, this is only an example, and the experienced teacher is going on teaching. The time allocation will not be uniform, and the content that is delivered also will not be the same. Now, when you classify this based on this Bloom's taxonomy, what is the level to which you teach will be very clearly given. So thereby they will be knowing where I have to stop. In this only up to applying, but in this I have to go up to creativity or creating. So the level of teaching can be very well decided with the help of this Bloom's taxonomy. And we have also seen that so this it helps very much in creating the lesson plan and also in the question paper setting. So this Bloom's taxonomy, this is the Bloom's taxonomy verb wheel, where all the verbs that you can use are given here. See, remembering. So what are the verbs that you can use here? Understanding, applying, analyzing, evaluating, and creating. So you can see to that you fit it. So that is why if you see, if you take a particular unit, it will be given to understand. So the working principle of this, to apply the knowledge gained here. So like that, you will be able to see the statements there. So it is all based upon this Bloom's taxonomy. Okay, where I have now highlighted a portion of the wheel where you can see the in understanding, analogies, discussion boards. How will you achieve that is also given here. So in understanding, you can use analogies, discussion board, drawing illustrations, journal entries, MC, multiple choice test, short answer test, simple comparison, summary, written report, outline. So this Bloom's taxonomy verb wheel gives the what are the verbs that you have to use, and what are the activity that you can do to check whether the particular outcome has been reached. So that what are the things you will be doing is also given here. Now this is the Bloom's tree, where you can see the various levels are given, like remembering, understanding, applying, analyzing, evaluating, and creating. And you can see the verbs also listed here. So Bloom's revised taxonomy with verbs. So the difference between the two is here will be in giving in terms of verbs. Action verbs like remembering, understanding, applying, analyzing, evaluating, and creating. So this is one part which I have taken. So remembering, where you can see that you have the list, identify, recognize, label, find, okay, recollect, remind, write, recall. So these are some of the verbs which you will be using for revised Bloom's taxonomy, the first level, that is remembering. Okay. So this is all about the Bloom's taxonomy, where we have discussed and how this can be used for the teaching learning, where you can fix it upon at the various levels. And nowadays we also have this concept of the flipped classroom. Okay, so flipped classroom. So it is not that all the learning should take place inside the classroom. So you can have some learning outside the classroom and some inside the classroom also. Okay, and some inside the classroom also. So we have this concept of flipped classroom. And outside the class, you have the traditionally delivered in class uh, series, which is given in the form of a video, such as lectures are delivered outside the class via web-based materials like videos, demonstrations, and tutorial simulation. Because now simulation, virtual environment where you can do all the experiments. So that also helps a lot. And the benefit is it provides faculty with more time to work, time in the class to work with individual students and allow the students to master the content at their own pace. See, because while learning the theory, I may be a slow learner, so I'll be going through the videos and I'll be learning it. And in the class, time is used for deeper engagement with content, while the instructor provides guidance through collaborative projects, individual and group problem solving, peer based learning activity. Okay, so in the flipped classroom design process, so you have the first level, that is outside the classroom. We are focusing on remembering, understanding, and applying. And within the class, we are focusing on analyzing, evaluating, and creating. Okay. So you are splitting up this Bloom's taxonomy into the lower level and also the, or you can say LOT, lower order thinking skills, and a higher order thinking skills. So outside the class, you select the content, select the delivery method, create or find the content, where you can make the videos and you can post it in your groups. The students are asked to go through the videos and learn and then come to the class where they can have some fruitful discussion. So in this way, you are able to save time, because the common thing that we can hear is the semester is very short. We don't have time to complete the syllabus. So when you go for the flipped classroom, you have enough time for collaborative projects, individual and group problem solving, and also the peer-based learning activity. Okay. So you have some of the references. So these are the topics which I wanted to cover under the teaching learning process. Maybe now I would like to invite you all to join for a quiz. Maybe after that, still if you have time, we will start our uh, next presentation. Okay. So I want all of you to go and log in to menti.com. Menti, MENTI. Okay. Menti.com. So you are able to see the code here, 49851242. Copy the link. 1 minute. I'll copy this. Three players are ready. Not able to click to copy the voting link. Voting link copied. Now I have to put it in the chat here. Chat. Send. So you are able to see a link in the chat box also, either one way. Code is 49851242. 4985. Maybe if you are seeing my screen, you'll be able to see that, or I can even type it.
In the screen, we are seeing your slide still. Maybe you have to reshare.
Oh, I have to change it. Huh?
Yeah, you have to reshare, I guess.
Share this again. Oh, the quiz has started. 1 minute, how to go back? It is ticking away. Time is ticking away. Maybe those who have joined, shall I go back and come again? Yeah, now I have to go and share my screen here. New share, yes. My presentations, share.
Yeah.
I think now my screen is visible.
Yes, ma'am.
Oh, already the question has come and first answer has also come. How many of you were able to answer? Only 3 have answered. I should go back now once again so that, or I have to restart it. I'll restart, reset the entire presentation, reset results, and I'll go and present here. It is showing the answer also. Okay, good, fine. Yes, now 15 players are ready, 16.
Madam, please share the code once again.
4985 1242. Okay, very good, very good. 20. Okay, very good. So shall we start now? 23 players are ready, very good. So here comes the first question. Which among the following is a law of learning? I've given 30 seconds. You can answer. Wow. Very good. Very good. 21 right answers. Really amazing. Okay. So moving on to the scoreboard. Oh. So you'll be able to see 10 names here. So we have Chayapati, fastest to answer, followed by Mathuri, Dr. Venkata Madhava, Ram. Somebody has not changed your name. Vibha, Madhukar, Hari Prasad, Umesha. Some number is also there. As students, you have given number, and Meghna. Very good. Now moving on to the next question. A relatively dash change in behavior is called learning. Very good, very good. So fast in answering, very good. Wow, now only we have 12 right answers. Permanent, relatively permanent change in behavior is called learning. Very good. Let us look into the scoreboard. So we have Dr. Venkata Madhavaram. Okay, no, Madhukar leading, followed by Meghna, fastest to answer this question. Dr. Sidandan Badigar, Umesha, number, Dr. Venkat Madhavaram. Somebody has not changed the name, Vibha, and the other two have not changed your name. Even then you can go back and change. Okay, now moving on to the question 3 of 5. Okay, 36 players, very good. The first pillar of learning as per the UNESCO report. You have seen 4 pillars of learning there. What is the first pillar of learning as per UNESCO report? Wow. So the first pillar is learning to know. Learning to know. And the next one is only you will be learning to do. That is understand, learning to do. And then it will be learning to be and then learning to live together. Okay. So very good. We have 16 right answers. Let us look into the scoreboard. Very good. We have Madhukar fastest to answer and also leading the scoreboard, followed by Umesha, Meghna, Sidandan, Dr. Venkata Madhavaram, Shekhar, Darshan, number Viba. Okay, very good. Now moving on to the next question. Question 4 of 5. Okay. What makes think, pair, share unique compared to other discussion teaching strategies? So we have seen the active learning strategy, think individually, then pair with the class teammate or classmate, then share. Unique compared to other discussion strategies. Very good. Very good. Very good. Gives time for the individuals to think independently. First, they are thinking. After that, only they are sharing, pairing, and then sharing. So, in this way, the first, when you ask them to write a code, they'll be thinking on their own. So, giving time for the individuals to think independently is the unique feature of this active learning strategy. So, let us look into the scoreboard. Okay, we have Dr. Venkata Madhavaram. Okay, Shekhar, very good, leading, followed by Venkata Madhavaram, Madhukar, Umesha, Meghna, Siddhanand, Venture. Who is Venture? Is a fast, he or she is the fastest to answer this question. Very good. Followed by Vibha and Arun Kumar. Very good. Now coming to the last question, question 5 of 5. Okay. The second level of Bloom's taxonomy is. What is the second level of Bloom's taxonomy? Very easy question. Somebody else is said to answer, so it's by waiting. Very good, very good, very good. 25 right answers. Very good. Understanding. So remembering, understanding, applying, analyzing, evaluating, and finally the pinnacle is the creating. Okay, or creativity, creating. Very good. Yes, let us see who's the leader of the scoreboard for today. Yeah, we have Madhukar. Very good. Congratulations. And followed by Umesha, Meghna, Vaibhav, then who's that Wolf Mister? Was not changed the name. Venture was not changed the name. Shekhar, Arun Kumar. Sir,
Shamanth is Venture.
who is Venture?
Shamanth.
Shaman. Okay, very good, very good. And Wolf Mister has also not changed the name. Shekhar, Arun Kumar, Dr. Venkata Madhavaram, and also the number. Somebody has
Number
given
is
the
Mohan Reddy.
Mohan Reddy. Very good, sir. Very good. Congratulations to all the participants and congratulations to the leader of the scoreboard, Dr. K. Madhukar. Very good. Congratulations. Yeah, now I think it is time for an activity where you can, now it is 1 o'clock. Maybe I think I can give you an activity. So what I would like to you all to do is take a topic that you are teaching and classify it into the various levels of Bloom's taxonomy. Can with an example, you can present it. Any one or two can present it so that maybe with the you can do it and you can present it later on also, no issue. So that you can practice it. Maybe I would like to know that what maybe how long is the course, and what are the topics that has been covered so far? Because when I asked Dr. Abhishek, he said that teaching learning process for innovative pedagogy, he said, yes, okay, ma'am, fine. And I started because I don't know what are, because your prerequisite is always very much required for us to teach. I didn't know the prerequisite, but anyway, as it was asked, because Monday only we were asked about the lecture and readily we accepted. So I would like to know what is the background. Maybe any one of you can just let me know. So it's a how many days program, and what are the contents that are being covered? And what is the background of the teachers who are attending this course?
Okay, ma'am. So we have, so recently who have joined from past couple of years, around 50 faculty members from various engineering and sciences. So BMS College of Engineering, we have around 17 UG programs.
Very
So,
good.
and PG also around 14, and then 15 research centers. So all the faculty members from all programs are there. We have mechanical. So Madhukar was from mathematics. We have machine learning faculty. We have medical electronics, mechanical, civil engineering. So literally almost every department of engineering we have. And
Very
even
good.
a couple of them from MCA. That's the background of participants. So,
And regarding the course, sir?
course, yes, ma'am. So first day we had one session motivation kind of thing for all faculty, why they should be faculty and what they should be practicing. And then afternoon they had more on digital learning, how they can create contents, how they can use NPTEL contents for teaching learning and other digital learning platforms. And yesterday, Neeti sir, he spoke about very interesting platform on how we can create online content using one link that is XC, yeah, xclearning.net. Yeah. So how we can create, and he gave demo of that, and all our faculty members who are present here. So for 48, so around 50 of them are there. 48 of them have submitted one assignment also using that. So they did all those things. That's still yesterday. And tomorrow they have one session on by one of the senior professor from college itself on how to take feedback from students and how you can comply on those things. And the last session, last 1.5 day, we have demo session. So all the faculty members who are present here, they will be giving demo on the teaching methodology. So how they should, I mean, they'll give how they have been teaching and what are some of the good practices. They'll come and give the demo, and few of the faculty members, other faculty members will comment on those things, saying this is good, this is not good, this is something you have to change.
Is it like a simulated teaching practice?
Not really simulated. So it's we are not doing any recording or anything. They'll go into one discussion room, and then one faculty will teach for around 10 minutes, and other faculty will give feedback on that.
So no recording and replay. It is just where you do it lively.
Yeah. So we thought we'll do recording, but I mean, the session which I'm leading, I'm planning to do on my mobile phone. I don't know about other experts how they are planning. I thought I'll do in their mobile phone and that will be their take home gift after the session. So that's for 1.5 day, tomorrow afternoon and day after tomorrow.
Okay, sir. Okay, very good.
It's a 1 week workshop, not
1 week workshop. Okay.
yeah, 5 days. Yeah.
5 days. Okay, sir. Okay. Very good. Thank you for the yeah, now only we are able to know that. Anyway, I was just messaging you and you were giving me some topics, but really I was wondering because when we do IDDS, we start with this teaching learning process. So that's why I was asking you whether anybody has covered this topic on teaching learning process, and also the other. Okay. Okay, sir. Okay. Anyway, nice to know that. Maybe now shall I move on to the other topic, or will they be able to? It is now 1:06. What to do now? Now shall we start the?
No, ma'am, we can have break. Maybe they can come little early. Instead of 2:30, they can come around 1:15.
Okay,
And we can start the session. We can wind up the session also early. If that's okay for you, ma'am.
Yes, it's not an issue. Yeah, now because if I start the next topic, part is the students, because we also should know about the other side. They'll be really finding it difficult to sit and learn now. So you can ask
it
them.
was interesting and engaging. I don't think any of them felt bored. But yeah, screen is always a little different than physical. So we'll give break now at 1:17 it is. So maybe we'll come back by 2:15. We'll have a lunch and come back by 2:15.
Okay.
Yeah.
Okay, sure. Okay, sir. Okay, sure. Maybe then I'll join at 2:15, where I can talk about laboratory evaluation, and we do some assessment techniques also, but I think the time that is given will be enough for lab evaluation. I'll just talk about lab evaluation and open-ended experiments.
Yeah, that's one thing, ma'am. When you told about lab evaluation, I was excited because none of the workshop which I attended at starting of my career taught about lab evaluation. That's something which we really need. And also open-ended experiment, we do use that word, but is that really what we are doing? Open-ended experiment that we learn from you.
Okay.
Yeah.
Okay, sir. Okay, then I will log in around 2:15.
Yes, ma'am. Yes, ma'am.
Okay, thank you.
Dear participants, we'll meet again at 2:15. Same link will be there. I'll just pause it for now and you can join. It will be open. Thank you all. We'll see you soon.
Yes, so welcome to the afternoon session, the post-lunch session, where we are going to look into the laboratory evaluation and finally open-ended experiments, and finally we'll conclude with a quiz. Okay. I think I can share the screen. I not open that. Okay. It's there. Yeah. So I think my screen is also visible.
Yes, ma'am.
Yes. Okay, we look into laboratory evaluation because we deal with the theory and we have the concerned practicals also for the subjects. So we have maybe for a semester, though we have some 6 theory papers and 2 lab. So these labs helps us in developing the skill. So in these labs, are we really practicing or developing the competencies, or we are giving more importance to the procedure? So if I put this question, so though uh, it is established or it is developed to improve the competencies, we focus more on the procedures. When the student comes to the lab, yes, they have to do this, they have to write the procedure, they have to draw the circuit diagram, they have to connect everything, and they have to do the model calculation, do the graph. So it's like more of a procedure which they have to follow while they are coming for the lab. So this lab evaluation is also a very important topic. As teachers, we should know how to evaluate the laboratory experiments without giving more importance to procedure, but giving very much weightage to the competencies that they are supposed to develop. Okay. So we know that we have the three learning domains: the cognitive, the affective, the psychomotor. So morning, during the teaching learning process, we were focusing on the cognitive domain, where we also dealt with the revised Bloom's taxonomy. Now we are going to focus on the laboratory experiments, where the students are going to use their hands to do the various experiments, and that is the psychomotor domain. Psychomotor, brain activity related to hand. So it is the psychomotor. And the third one, it is the affective domain. Affective domain, you can say that it is the attitude, the values, the feelings, all these come under this affective domain. Like how we have the theories related to the cognitive domain, you have theories associated with the psychomotor domain and also the affective domain. And also here we have in cognitive, we have revised Bloom's taxonomy, where we have the 6 levels. Similarly, we have various levels in psychomotor domain and also the affective domain. So cognitive, it is associated with the brain. Affective domain, it is associated with the heart, the feelings, the values. Psychomotor, it is activity, hand, activity based psychomotor. Okay. So this was what we were discussing in the morning about the cognitive domain, where we have the revised Bloom's taxonomy. And we move from remembering to creating, that is from simple to complex or concrete to abstract. Now in revised Bloom's taxonomy, we have, so earlier it was you will be just classifying this under remembering, understanding, applying, analyzing, and evaluating. But now it has become a 2D picture where you give importance to cognitive and also the cognitive process dimension. And also here you have the knowledge dimension. See, for example, you have to map the cognitive process and the knowledge process dimension. As the morning example I have given, I will just take that. I want to fit in an objective, that is explain the working principle of a diode. Okay, it is like or describe the working principle of the diode, which comes under the understand category. And now, so I know that in the cognitive process dimension, I'll be fixing it under this head, that is understanding or understand. And now coming to the knowledge, where will really that fit in? So is it a factual knowledge or a conceptual knowledge or a procedural knowledge or a metacognitive knowledge? So here you can see under conceptual knowledge, the knowledge of classification and categories, principles, theories, models, and also structures of a subject. So this is principle. We are going to describe or explain the working principle of a diode. So I can say that this objective will fit here in this column. Okay, in this column and in this row, I'll be able, it's as it is a 2D. I have to map it with the cognitive process and also with the knowledge process dimension. So I'll be mapping it here. So like that, you'll have to map each and every objective that is there in your curriculum. So you will be knowing to what level you are teaching to your students. So that is what we do in this revised Bloom's taxonomy, where we do the mapping. So the next one that we are going to see here is the affective domain level. So which is more related to our feelings, our heart, and our values. Okay, so this affective domain, we have a theory or a taxonomy behind that, which states that for the affective domain, the various levels are receiving, responding, valuing, organizing, and also characterizing. So you have to, the affective domain, maybe it's I think Krathwohl's theory. I didn't give the name of the theory. So the first level is receiving. Okay, receiving. Receiving is you're open and you are very attentive. You want to learn the particular thing. So you have an attitude towards that. Okay. So the being aware of or attending to something in the environment. You can use the verbs like listen, notice. And an example that is given here is you listen attentively to badminton introduction. You are very much interested to learn badminton. So you have an attitude towards learning that. You are focused to learning playing badminton. So receiving, the first level, you are open to receive maybe the rules of the game or how to play the game, whatever is being taught to you. You are open to receive that. Receiving is the first level. Second level is responding. After receiving, I should not keep it within myself. I have to respond to that, showing some new behavior as a result of experience. Now, what you have learned, you have to show that, responding. Okay, responding to that. You can have like comply, enjoy, follow. So you are responding by voluntarily helping to set the badminton court, the badminton nets. So this shows that you are responding. Third one is valuing, showing some definite involvement or commitment. Carry out, express, these are the verbs you can use. And you attend optional badminton match. So you are attending the optional matches so that you learn how that is played and how you observe how the players are playing and so on. The fourth one is the organizing or the organization, integrating a new value into one's general set of values related to other priorities. So now you are going to integrate a new value because you want to learn that. And you have other general set of values. Apart from that, you are adding new values to that. So you can say the verbs like choose, consider, prefer. Now you prefer to purchase your own badminton racket. You're organizing yourself so that you want to get into the badminton team or you want to play the game. Finally, it is the characterization. Acting consistently with the new value. The person is known by the value. So you want to become that. So you consistently you act with that new value and you are known by that value. So now you act on, depict, exemplify. So now you play badminton. Finally, your objective is to play badminton for your team. So when you are having that attitude towards that, you do all these things so that finally you become a player. So the levels are like how we have the 6 levels: remembering, understanding, applying, analyzing, evaluating, and creating. Here we have in this Rathwall's taxonomy, receiving, responding, valuing, organizing, and characterizing. Okay, the characterizing is the top, where you become that character itself, what you want to become. So you want to become a player, so you characterize it, you act consistently, you act upon that, and you become a person with that value. So this is the levels in affective domain. Now our session is on psychomotor skills. We are interested in psychomotor skills. Okay. So this is, maybe I think one slide, it is there. This is affective domain. Okay, Rathwall's taxonomy, where you are receiving or attending, receiving, responding, valuing, organizing, and characterizing. Okay. Now we are moving on to the psychomotor skills, where you have psycho, which is associated with the brain, and motor is the hand. So associating the brain to do certain activity in the laboratory, we call it as the psychomotor skills. Now in this skill learning, morning, for the theory of learning, we have seen Thorndike's trial and error theory of learning. So now for this skill learning, we are going to look into Pavlov's skill, that is stimulus and response. How he is giving the stimulus and getting the response. Before that, certain terminologies related to that. In skill learning, you have a response chain, movement coordination, and response pattern. See, anything, you take a plant, you put it in front of your door. Now you can see the plant will go towards the sunlight. It will move towards the sunlight. So here your stimulus is the sun, and the response is the plant going towards the sun. Okay, stimulus and response. So these two terminologies are very important in skill learning. So you have a response chain, and based upon this response chain, you have a movement coordination, and finally a response pattern. So the response chain, it is a skill. A skill is a chain of stimulus response, SR, what we call a stimulus and response. And these are put in the form of units executed in a particular sequence. That is the response chain. Okay, the first one, we have the response chain. I just gave a simple example of a tree, of a plant going towards the sun. Okay, the stimulus is the sun, response is the movement towards the sun. So if you are going to focus on a skill, it will have a chain of such stimulus and response executed in a particular sequence. So you have to mastery a skill. Now for skill, we don't say there is a pass or a fail. Skill is mastery. So see, maybe you want to do or you want to learn the skill of driving a car. Skill of driving a car. So the question is whether you will be able to drive a car. Yes, you have achieved mastery. No, you cannot say I have achieved say 50% of the mastery, 30% of the mastery. No, whether mastery is yes, you will be able to drive a car. No, then you have not achieved the skill. You have to go back, learn and come. Okay, so these are the stimulus and the response to learn a skill. And the gradual change from reliance on external cues. First, when you are going to learn driving a car, you totally depend upon the person who is sitting next to you, and you ask them for the guidance. He will say, yes, yes, you start the car. Yes, now you give the accelerator, apply brake, move in this direction, that direction. So they'll be giving you various instructions, various stimulus, and you are going to respond to that. Now, after that, when you gradually change from all these external cues to internal cues, then you have achieved the skill. Now, no need for all the external cues. Only you're going to rely on self, because I know the skill of driving. I can start my car and I can go on my own. So now you have mastered the art of driving the car. The movement coordination, a skill learning requires high degree of eye and hand coordination. You can see the bar benders doing the bar bending. So it is with such a perfection they will be doing that. And it is the eye and the hand coordination. Okay, so they do it, and by practice they will be able to coordinate the eye and the hand, and they'll be able to do it. Hence they are called perpetual motor skills. Okay, movement coordination. And finally, it is the response pattern. This stimulus response units, and hence the stimulus response chain, they constitute a large response pattern as subtasks or subroutines, which are hierarchically organized into larger response pattern. See, I have to do this the skill of driving a car. I can divide it into certain subtasks. Okay, so I can now first sit into the car, start, and then all these are subtasks: starting the engine, then releasing the brake, and then accelerating the car. Each one is a subtask. So all these subtasks put together, and they are hierarchically arranged to form a larger response pattern. So the skill is the total response pattern. Finally, you are able to achieve the skill. That is the total response pattern. So for any skill learning, you should have a stimulus, a response. So large number of stimulus you put together. Okay, large number of stimulus response. You get a response chain, movement coordination, and finally the response pattern, that is you have mastered the skill. So instruction in skill, whatever task is given, you first analysis of the task, assess the entry behavior of the student. Okay, some task is given. So first analysis of the task you can carry out, assess the entry behavior of the student, arrange the training in the component unit skills or abilities, describe or demonstrate the skill to the student, provide the basic learning condition. Okay, so whenever a task, even for a laboratory experiment is given, you can divide it into subtasks. Okay, then you should know what is the entry behavior of the students. After that, you arrange the training in the component units, skills or abilities, and it is the duty of the teacher to give a demonstration of the skill to the student. Maybe you want to use a CRO. How will you check the waveform in a CRO? So that you can make a demonstration of that and provide the basic learning conditions. You have to facilitate the learning by providing the basic learning condition. So this is a Russian physiologist, Ivan Pavlov, who first said that for every thing, there is a stimulus and a response. He was conducting his study with the dogs. Morning I said Thorndike with the help of cat, he was explaining the loss of learning. So Pavlov, a Russian physiologist, he conducted lot of studies with the dogs. Maybe I can show you, though we have, this is the slide which explains Pavlov's study. So first for his study, he took a dog, and he didn't show any food. No food was shown to the dog. So it is a unconditioned, food is separate, dog is separate. So there is unconditioned stimulus, and there is a unconditioned response. There's no response, no condition. That is before conditioning. After that, what he did, every time he made a bell to ring. He made a bell to ring, and after the bell, he immediately served the food to the dog. Sorry, the first one is that is natural. It's not separate. Whenever the dog sees a food, naturally it will start, the saliva will start to secrete. So that is the first condition before conditioning. There's no condition at all. Whenever you show the dog the food, it starts the saliva secretion. That is the first condition. Then what he did, he didn't show the food. He started ringing a bell. He started ringing a bell, and there was no response. And there was no response. Okay, so the dog was quiet. Now during conditioning, what is it? There was a ringing of a bell. And after the ringing of the bell, he started serving the food. So when the bell started ringing, the dog will know that the food is going to come, and immediately the saliva will start to secrete. Now, after conditioning, even when the bell goes, there's no food. Even when the bell goes, by the time itself, the dog understands that it is about to get its food, so it starts secreting the saliva. So in skill development, you have the phases like before conditioning. Before conditioning is something natural, but after that, when you give the training, during conditioning and after conditioning. So Paulo related this to skill learning, where he said you have the stimulus and the response. The stimulus is the food, and the secretion of the saliva is the response. Second one, the stimulus is the bell, but there is no response. After, that is during conditioning, it understood that, yeah, when you have the stimulus, that is the bell, immediately food will come. Unconditional response. Finally, it is a conditioned stimulus and the conditioned response. So in skill learning, you have to move from this unconditioned stimulus, unconditioned response to conditioned stimulus and conditioned response. That was the theory that Paulo has suggested. Now let us look into the hierarchical order of categories in psychomotor domain. The theory that is related to this is Dave's, R.H. Dave's theory. So the three theories, one is Bloom's taxonomy for cognitive domain, Rathwall for affective, and R.H. Dave for psychomotor domain. Okay. Now let us look into this hierarchical order of category in the psychomotor domain. So when an instructor desires to move a group of students through a learning process, utilizing an organized framework, Dave's taxonomy can prove helpful. Okay, Dave's taxonomy can prove helpful. So there are 5 levels in this psychomotor domain. Okay, so this finally at the end of this, you will be achieving the skill learning or mastery in the particular skill. So what is the first level? The first level is imitation. Okay, first level is imitation. So they're remembering, they're receiving. Here it is imitation. Okay, imitation. The next level is manipulation. Manipulation. The third level is precision. The third level is precision. The fourth level is articulation. And the last level is naturalization. Okay, last level is naturalization. Now let us look into each level. Okay, the first level, that is the imitation. Imitation. Maybe I can give it an example before going into the terminologies and the explanations that are given there. So imitation. So this is much related to psychomotor domain. So we will take up our laboratory experiments. So first one is, normally how do we practice our laboratory? We call the students, we give them a list of experiments. And this is the first cycle, a list of experiments, second cycle. Okay. So you ask the students to do the experiments, and before going to the cycle, you give a demonstration. You give a demonstration of the various apparatuses that you have to use and also the experiments. So that demonstration is very well observed by the students. That is what we call as the imitation. So you are doing a particular experiment, and that is very well observed by the student. And after that, he tries to, imitate the teacher. Imitate, that is what we call as imitation. So whatever the teacher does, as I said, the example, now just adjusting the waveforms in a CRO. I remember very well that when our teachers come, normally when we do the experiments, we will not get the waveform. So I'll be waiting for the teacher to come and get the waveform, and the teacher will come and make some adjustments, and finally they'll get the waveform. Now we'll be very much observing what the teacher is doing, how she's changing, or he or she is changing the time division, the amplitude, and the other trigger and other buttons. So next time we will try to immediately do the same. That is what is happening in imitation. The student observes what the teacher does and try to imitate the same. That is imitation. The second level is manipulation. Now you have taken a note of what the teacher does. Okay. And then you are following those instructions and you are doing the laboratory experiments. That is manipulation. Being able to perform certain actions by following instruction and practicing. See, that is how after the lab exercise, when some model exam is there, students come to the lab and they do the practicing so that they become familiar with the experiments. So now they are able to perform the experiments by following instructions. Okay, that is the second stage. Third one is the precision. They are able to execute the skill reliably, independent of help. Now no teacher is required, no learning material is required. They are able to do it individually or independent of help, perform a task or activity with expertise and to high quality without assistance or instruction. No need any instruction. Now they are able to do. First they were imitating the teacher. Manipulation, with the help of the notes, they were trying to get the result. The third is no such support is required. They are able to do this to the fellow batch. So one batch has completed. The next week, the next batch is going to come. So the first batch can precisely demonstrate what they have done the previous week to the next group students without having any supporting material or support from the teacher. So that is precision. Okay. Moving on to the fourth level, that is articulation. Okay. Articulation is you are coordinating a series of action. It's not only one action. Maybe in one experiment, you have 3 parts. You're coordinating all the series of actions and you're achieving a harmony and internal consistency. You're achieving a harmony and internal consistency. So adapt and integrate expertise to satisfy a non-standard objective. So what is your objective? You need to find the efficiency of maybe a shunt motor, or you want to conduct a load test on a transformer, whatever may be your exercise that is given. All the exercises, maybe the sub experiments also you will be able to do, and you will be able to integrate all the expertise and show the result. Okay, and show the result. That is articulate. And finally, it is naturalization. So naturalization is automated unconscious mastery of activity. So here you have to underline this. It is automated unconscious mastery of activity and skills at strategic level. So whenever you are asked to do that, you will be able to do it. Okay, you'll be able to do it. So that is the practice you have to do, so that finally when you are asked to do that, you automatically and unconsciously you are able to achieve the mastery of the activity and related skill at strategic level. You would have seen some of the car technicians, with the sound of the car itself, they will be able to tell what is the problem or within the engine, or what is actually the problem. They'll be able to identify very well. So that is because of this automated unconscious mastery that they have achieved in their trade. Okay, in their trade. And normally when we give some uh, tips to our students, we'll ask them, see, you have to learn very properly. Even when I ask in sleep, you have to give the example or give the answer. The same thing is automated unconscious mastery. Whenever you are asked, or whenever you hear that, automatically that should come. So this is how we have to train our students in the laboratory. So when such an experiment is given, automatically they should be able to perform that. They should reach the level of naturalization. This is what Dave says. For a psychomotor domain, first make a demonstration which the students can imitate. With guided practice sessions, they can do the exercise. Without the help of anyone, they can do precisely the experiments. 2 or 3 subtasks are there. They can do everything and give the result, articulation. And finally, it is the automated unconscious mastery, which the students should achieve. So if they are achieving this mastery, whatever exercise you give in the lab, they will be able to do it. So Dave says you train the students to this level to achieve the naturalization in laboratory practices. So like Bloom's taxonomy, here also we have some of the verbs that you can use for the various levels. We have imitation. So you can use, actually imitation is observe skills and attempts to repeat it. So you can use these verbs like adjust, adhere, change, clean, copy. So these are some of the verbs that you can use for the first level imitation. Okay. Now the second level, that's manipulation. Perform skills by instructions rather than observation. So you have a teacher. Thereby you'll be able to perform the lab experiment, perform skills by instruction. So you have some of the verbs associated with that, because to indicate that it is in this level of the psychomotor domain, the waste theory. So you'll have to indicate for manipulation. So these are the verbs that you can use. Third level is it's a precision. It is reproducing a skill with accuracy, proportion, and exactness, independent of the original sources. You don't have any other support material or anything that was supporting you. You are able to reproduce a skill with accuracy, proportion, and exactness. So these are some of the verbs that you can use: identify, locate, manipulate, modify. So okay. Articulation. So articulation combines more than one skill in a sequence with harmony and consistency. So what is required to achieve in that particular skill? The subtask also you should be able to master. Okay. Combines more than one skill in a sequence with harmony and consistency. So these are the verbs: conduct, pull, push, set, sketch. So these are the verbs you can use for articulation. And finally, it is the naturalization, where you say it is the automated unconscious mastery. Automatically it should come. And you have certain verbs related to that also. Okay. So now this is the 5-step process in psychomotor training. So the first one is, see, as you know that now more importance is given to skill development. So for skill development, as more emphasis is given, and we should know that we have to focus on these levels for developing the skill, and you have to come up to the level of naturalization. Okay, you are not supposed to stop with precision. Okay, so you have to, precision is doing without any guidance, precision, and then you have articulation and naturalization. So you have to come up to the level of naturalization. Why the skill is needed and how it is used in the delivery of care. Okay, first one. Second, first you have to identify why this skill is needed, why I should master this skill. Second is a silent demonstration by the teacher. The teacher makes a demonstration of the particular skill. Repeat the procedure, but explain in detail. Students verbally describe the procedure. So now that is what the students do. When they come to the lab, they write the procedure. Everything is ready in the observation book. But when you ask them, I don't know whether they will be able to give the procedure and whether they will be able to identify the right equipment, right devices, and connect it in the lab. But they will be able to show the observation book where everything will be very perfect. Students perform the skill with preceptor feedback. With the teacher's feedback, the students are able to perform the skill. Now, normally, when you come to the laboratory session, so what the students do, they come with the observations, everything ready. And even sometimes the readings will also be ready. So they just do the calculation, they plot the graph, they show, and they leave off. The time allocated may be 3 hours, but before that, by 1 hour, they will be completing, and then they will ask, shall I go? Then we will also say without any other, we will say, yes, okay, have you completed? Yes, then okay, we will say you can go. So the time allocation during the laboratory sessions, 15% of the time can be given for explanation. Maybe you are showing certain devices, connection of certain devices, and all those things. 15% you take for explanation. 10. Then for demonstration, you can take 25%. 25% of the time for demonstration, because in the laboratories we are very much worried that the students should not damage the equipment. So then the faculty in charge is responsible for that. Each and every device equipment will be costly. So you make a demonstration, and normally we say in the laboratory, without the teacher's advice, you are not supposed to switch on the circuit, switch on the supply. So that is how we very strictly tell them. So you can make some demonstration for the required apparatus, and for the remaining 60% of the time, you give them the practice. Don't allow them to go out of the lab or leave the lab until they are reaching the stage of naturalization. Okay, they are practicing it again and again. So that unconscious automated mastery should be achieved. Yeah, this is the retention rate, what we have seen in the morning session. Yeah. So for practice, really we have 75 to 80% is allocated for practice. So more you give them the practice, the more the confidence level will increase, and they'll be able to do the laboratory exercises. Now here I'm going to show a sample laboratory handbook that was developed by one of our professors who was then in Extension Center, NITTR Chennai Extension Center, Hyderabad. Okay. So he has developed a handbook for laboratory courses where he has divided it into 3. So the material that is relevant to the teacher, material relevant to the student, and finally the observation or the observation sheet or the record book. So this will surely be a role model for us in framing the laboratory exercises. Okay. So first, it is a handbook on communication lab. So this handbook is designed to overcome the shortcomings of existing laboratory instruction methodology. Whatever shortcomings are overcome in this handbook on communication lab helps in better organization of the laboratories, guides teacher in conducting the experiments, greater student satisfaction, and relieves the students from writing or copying the records, and ensure consistent quality. Okay, ensure consistent quality and scientific evaluation of the students. Scientific evaluation of students. So the handbook is divided into 3 parts where we have the laboratory sheets, the worksheets, and the experimental methodology. So first one, that is the laboratory sheet. So this laboratory sheet, it is meant for teachers and it serves as a teaching plan. It is mainly meant for the teachers and it serves as a teaching plan, like a lesson plan for the theory class. What we do, we prepare the lesson plan. And here for the laboratory exercises, it can serve as a teaching plan. It helps in organizing the laboratory session and ensures consistency, because all teachers will have the same handbook. It is uniform. Consistency will be maintained and helps in time budgeting, improves quality. So if you have a common handbook on a particular laboratory, so that will be followed by everyone throughout the state. So you can ensure consistency and also the time budgeting can be done, and this improves the quality. So the main features of the laboratory sheets are, first one, you will have the objective, the task analysis, teaching points, need and scope, planning on organization, scheme of evaluation, assessment questions, and vivos. So if you are planning to go for developing material or developing manuals for laboratory, you can follow this. You can develop it as laboratory sheet, which is meant only for teachers, worksheet for the students, experiment methodology, which can be used both by the teachers and the students. So in this laboratory sheets, you should have all these features. These features like objective, task analysis, what are the teaching points you have to cover for the particular experiment, need and scope, planning and organization, scheme of evaluation, how are you going to evaluate, assessment questions, and vivos. So everything is put here as a laboratory sheet. Okay. So the first one, that is the objective. It specifies the task to be accomplished. That is the objective. We normally write the aim of the experiment. So that is the objective. Example, to calculate the modulation index of amplitude modulated wave by observing the waveform in a CRO or on a CRO. So you are going to calculate the modulation index of amplitude modulated wave by observing the waveform on the CRO. Your objective is very clearly specified. So the next step is task analysis. So task analysis is how you are going to split this experiment so that each small step will be completed to achieve the final objective. So subtask to accomplish the goal. What are the subtasks you have to do to accomplish the goal? What is the knowledge requirement, the prerequisite? If the student has to perform this experiment, what is the prerequisite that is required? The knowledge requirements, the skill requirements. What is that? So this has to be listed. Okay. What are the subtasks? What are the knowledge requirement and the skill requirement? Teaching points. So teaching points help the teacher to completely impart knowledge and skills required to perform the experiment. So the completely impart knowledge and skills required to perform the experiment. Organize the laboratory, achieve better student satisfaction, and limit the theoretical inputs to a maximum of 15%. So in teaching points, we just give what is required for the experiment. Limit your theoretical inputs. So as teachers, you should not go on lecturing. Limit the theoretical inputs to a maximum of 15 minutes. Okay. Need and scope. So need and scope, this explains the purpose of the experiment. Why? Why do you want to do this experiment and what is the scope of the experiment? Its usefulness in the field. Now you are going to tell them because of doing this, you will be able to carry out this experiment or this practical exercise, real-time application. So this will motivate the students. Its usefulness in the field, various other applications where the concept is used. Now the planning and organization helps the teacher to identify the resource requirement. Okay, you are going to plan for that, arrange the setup for experiment, prevent wastage of time, improve student motivation. See, normally here, because I don't know what is the actual strength in your classes, but normally in colleges, if you see at least 40 to 60 students will be there in a class. So this class, you'll be divided into 2 batches. One will go for another laboratory, one will go for another laboratory. So at least 30 to 40 students will be there. And these 40 students will be sharing the resources in the laboratory. So CROs and the function generators, all these things you will not be getting. So we'll have to wait till one batch completes. Then you'll go pull it out from there and then you will be doing it. And when you're doing, you'll not be able to get the result also. So you'll have to, meanwhile, the other group will be ready to pull away the equipment from your table. So if you are planning ahead, how many CROs I have, so how many experiments I can give. Okay, so I can plan for that so that there is no wastage of time. I can arrange the setup and I can keep so that the students can, not the setting up, but arranging the equipment and keep so that the students can come and get all the apparatus that is required and start setting up the experiment and doing the experiment. So this will improve the student motivation. So otherwise the students will always give the complaint that, no, this is not working, that is not working. We are not able to complete the exercise and so on, experiments and so on. Next is the scheme of evaluation. The teacher to identify the strength and weakness of the student, to evaluate the award of marks to the student correctly. Okay, so student gets a scope to correct his mistake. You can say, now here you have not mentioned this in the graph, or you have not mentioned the units. Normally we forget to mention the units in the axis. Okay, so that will always be a question mark. So you can tell what is the mistake that is done there. So students get a scope to correct his or her mistake. The teacher to modify his or her teaching strategy. So if still the students feel that they are not able to follow, it is now the time for the teacher to modify the strategy, improve student motivation. So this will improve the student motivation and it ensures satisfaction on both sides, teacher and the student satisfaction. See, this is a scheme of evaluation. If you have drawn the circuit diagram, yes, this is the mark you will be awarded. Okay. So everything can be very fair and open so that it ensures both teacher and student satisfaction. Eliminates partiality and injustice. So if you have given the mark, yes. If that is not written, no marks. Okay. And finally, the assessment questions and Viva OC. So questions included for summative evaluation in the end examination. So as you know, in evaluation, we have the 2 types of evaluation. One is formative and the other is summative. Formative, during the process of the laboratory course itself, you can evaluate with simple subtask and so on. And this at the end of the semester, the examination that you are going to conduct is the summative, because that will serve as a judgment for them whether they are really qualified to pass in the examination, or whether they have, we now look into like that, whether they are really qualified to pass in the examination. But what Dave says is it's not only passing, it is naturalization. Set up at 3 levels. So now when you are giving a question, normally you will have a single question like determine the efficiency of a shunt generator having these properties and so on. So, and or a single experiment, conduct the open circuit and short circuit test on a transformer. So like that you have a single question, but instead of that, you set up at 3 levels. One can be a lower order, just measure the resistance or something like lower order, and then a middle order, and finally a higher order. So now we are testing the 3 skills, the lower order, the middle order, and also the higher order skills. So your question paper can be set in that way. Now we have the Viva OC also to ascertain that the students develop the expected skills and concepts. So oral questioning to ascertain that student develops the expected skills and concepts includes questions related to experiment. Pratibha, including questions related to experiment, skills involved in experiment, okay, and also the course content. This is the Viva OC questions because we have a theory subject and also the practical subject. So maybe if you have a question on, it's a machines lab where you're doing the lab experiment on machines, the questions related to the course content will also be put to you. So you have to get, so those important questions, you can add it in the Viva OC here. Okay, in the Viva OC here. Finally, the applications also. Applications also you can list. So these questions also you can have. This is a teacher material. This will not be given to the students. So the teachers can have this. What are the basic questions they have to put forth in the Viva OC examination. So next is worksheet. This is for the students. When you're preparing, it can be prepared as worksheet for the students. This is meant for the student. It contains details of the student and the experiment. You can take this as attendance sheet also. Students record his observation in this sheet. Serves as a purpose of students' attendance. Develop the skill of report writing. You don't give the procedure. So you ask the student to write the procedure. So this develops the skill of report writing and helps in lab maintenance also. Okay, so that is the worksheet. Now, what are the features in this worksheet? So you can have the student details, the objectives, apparatus required, procedure, graphs, calculations, discussions, scheme of evaluation, so on. So these are contained in the worksheet. Okay, so this worksheet, the student can complete it, submit it, and go. That's all. No need to have a separate observation and observation notebook and so on. Okay, so the student details, the student will enter the name, branch, and so on in the top of the sheet. The objective, the student writes the objective given. Okay, the same objective as for what they are going to perform this experiment. To calculate them are the same. Okay, your objective or aim is written there. Apparatus required. So the student has to write what apparatus he has to collect from the stores or from the department to perform the experiment. So helps the student to remember the apparatus and choosing the right apparatus. Builds concept of choosing the right apparatus. If you already give the apparatus, then they will not ask for what is the apparatus that is required. So you ask them to select the apparatus that is required, and then the procedure. Students write the procedure in his or her own words. Don't insist on writing like this. So they can now enhance the writing skills. Helps the students to develop report writing skills, understand the experiment, the graph model. Students, yeah, they draw the graph in the space provided. Standard graphs are included, so you can have a compare and analysis. And finally, the calculations, model calculations can be given. Discussion. So discussion is mandatory. So what is your result? So though we have certain standard values for certain experiments, even if the deviation is much, then you can give the justification. Discussion is mandatory. And this finally the scheme of evaluation. So student writes his or her observation based on the results, compare and analyzes with the standard result. From there, you can draw the inference. Now, scheme of evaluation, awarding marks in the appropriate columns for various skills. Okay, then scope for advising the students to improve certain skills, and you can keep it as a record for final evaluation. So what are the marks that they have got? You can put it there and you can keep it as a record for final evaluation. Now, the third part is the experimental methodology, where you have the material and also the self-learning packages. This is meant for both teacher and student, serves as a reference, includes theory, detailed procedure, sample calculation, graphs and waveforms. Self-learning packages, as you all know now in colleges, they don't do all the demo. It's all flipped classroom, where all the classes are recorded and sent to the students in the form of a learning material or a learning package. So where they can go through that and learn that before coming to the class. So this is meant for both the teacher and the students, and this serves as a reference. It includes theory, detailed procedures, sample calculations, graphs and waveforms. Okay. So that is the self-learning package. Now here I have shown a sample. Okay, how will you prepare for one exercise? Maybe to find the modulation index of amplitude modulated signal, this experiment. So the task analysis. Okay, what is the knowledge that is required? What is the knowledge they should know? That is A, under given the category A, principles of analog modulation technique, amplitude modulation, frequency. So these are some of the prerequisite of before doing the experiment. A part is knowledge that they should have. B part is the skill. Skill is they should know how to handle the experiments. Handling of apparatus, manipulation of apparatus, precise operation of activities. So like identifying the kits, identifying the components, identifying the test points, then reading the circuit diagram, selecting appropriate ranges in the multimeter, okay, testing the voltage levels of the multimeter. Similarly, precise operation activity, adjusting the time based on the CRO, aligning peak points of waveform with reference, identifying the peak points, measuring the amplitude. So like this, what is the skill that is required in observing the values? The teaching points. So the teaching points, like they should teach need for modulation for 3 minutes. So with proper time duration, if you give, these are the teaching points which you have to tell for laboratory exercises. If these are identified, and they will be able to, the students will also able to, the teachers will be easily able to deliver the teaching point that they should cover for the particular exercise. The students will also be able to know what is that they have to learn and come for the laboratory session. Before coming, what are the prerequisites that is expected out of them. So the model graph, the waveform that is observed, the carrier signal, modulating signal, and then the EM. Now this is the category of skill, the subtask, weightage with competency level individually and for the total. Okay. So handling of apparatus, identification of correct meters and everything. So you can give some weightage. Manipulation of apparatus, circuit connection, equipment handling, measurement and observation, precise operation of activity. Okay, and the 5 marks. The values, cooperation, coordination, communication, sharing. So another 5 marks. So you can give for this, you can always change according to how you want to split up, you can split it up. Okay. So in this way, we will be able to give the proper weightage for the topic so that you are able to judge the students correctly. So how they have done. You're not just giving the marks, though we have some split up. Okay. Now, if you have the material prepared like laboratory sheet for the teachers, worksheets for the students, experimentology, this will serve as a, I think they have done this for the state of Telangana. Okay. So like all the labs has been standardized. So for all polytechnics, so the handbook will be given for communication lab. So everything will be standardized, so everybody will be following the same. So that is why it was given the advantage is consistency. So what they should teach, what the students should learn, everything will be very clearly given here. Now, instead of practicing only the procedures, you can make them really achieve the skill, and even in skill up to the level of naturalization, they can establish themselves by practicing the experiments again and again. So this is what we have in laboratory evaluation or lab evaluation. So nowadays it is more of procedures. We have to change it to competency-based laboratory exercises, where the focus is on Dewey's taxonomy or Dewey's levels of psychomotor domain. Okay, so this is on the laboratory evaluation or how will you really evaluate the laboratory exercises, and what is the underlying theory behind that, what you should follow to evaluate the lab experiments. Do you have any questions in this? Or next we will move on to open-ended experiments. Okay. Shall we move on to then open-ended experiments?
Madam, continue, madam. Continue.
Okay, ma'am. Okay. Maybe I'll close this presentation.
Excuse me, ma'am.
Yes, sir.
Hello. Yes, ma'am. Ma'am, you had told that low level, mid level, and high level questions can be given in the session ending examinations in the practicals. So, how much marks should be allotted for them? Is it equal one
Accordingly,
proportion?
yes, accordingly, you can split up the marks. Maybe in the lower level, you just want to make them to identify some of the equipment. So, and if they have identified exactly, maybe out of 50 or out of 100, what is the mark you are giving? You can first
100.
decide. And then for the lower order, maybe you can have 10 marks, whether they are identifying proper or 5 marks. It depends upon what is the weightage of the total experiment. What is the weightage that you are going to give for the lower level? So as a teacher, we can decide that. Next, the middle level. Maybe if they are doing, you have some subtask which they are completing. So for that subtask, you can give them some marks. And finally, the full experiment where you are expecting the final result by combining all this. So that can be given the other weightage. So like maybe if you have 100 for the higher order skills, you can give maybe 60 and then 20 or 30, 10. So like that you can, it all depends upon how important you feel that that particular task is contributing to doing that experiment and getting the result and analyzing the result.
Thank you.
Here, normally I will give an example. So like maybe once I visited in IIT Madras, the electrical engineering laboratory. So where they have totally renovated the laboratory, and it is a machines lab, but what they have done is the machines are all put at the back side of the table, and in the front you will be able to see only a monitor. Now through the DAC, data acquisition card, you are taking all the data like the voltage, the current and everything, and it is fed into the system, and all the worksheets is there in the system. They just do everything, plot the graph, and there also discussion is mandatory. So, and here the only thing is the students come and do the experiment at their own pace. It is not like you have a regular laboratory class. No, labs are open. They come, they do, they finish the exercise, they save it and they go. So that is how they do the experiments. So in that way, so that is you're really no discussing, no copying the results, no cooking up the values. So everything what they perform, they record, they try to establish the result. If they are not able to get that, they give some justification for that, how they have derived. Maybe the lab in charge, they will go through the observation. If that is not satisfactory, they will ask you to redo. So then you'll have to redo the exercises. So in that way, now from the conventional laboratory experiments, we are moving on to achieving mastery. Any more questions, sir?
Madam, you continue, madam.
Okay, ma'am. Okay. Now I have to. Maybe I will open that and come here. Are you able to see this? The open-ended experiments.
Madam, no, madam. Only PPT is seen. Self-learning package.
Oh, okay, ma'am.
Madam, now we can see your PPT, madam. A lab course and learning.
Lab course, yes, ma'am. So now we are focusing on open-ended experiments. Open-ended experiments. So this open-ended experiments, it is not, see now our conventional lab practices, as I said, we have a list of say 15 or 16 experiments where we give them, we divide it into 2 cycles. We ask them to do the aim, the objective, the procedure, the circuit diagram, everything is given to them in the
Madam,
learning.
1 minute. Slideshow you should do, madam. PPT slideshow.
Slideshow, ma'am. Now I am getting it a slideshow. There you are not able to see it a slideshow.
No, I think you should press that enable on. We are in We are not seeing the slideshow. Side pan is also there and the slide is also there actually.
Now, ma'am?
No, madam.
No?
No, no. Maybe you can close. Now it's coming, madam. No,
Okay,
it's coming.
okay,
It's
ma'am.
coming. You
Okay.
continue, madam. Continue.
Okay, okay, ma'am.
Hmm.
So we have been discussing about our conventional lab exercises, practices, as where we focus more on procedures rather than developing the competencies. So now we have the concept of this open-ended experiments, which says that you don't give everything to the students. Okay, so there you have the various levels like level 0, level 1, level 2, level 3. So each level has got like exposing the students to at least some of the way in which they can think and they can do the experiment. So that is what we call it as the open-ended experiments. Okay, so a lab course is not a lab course and learning. So the lab course is normally a part of the curriculum, and you have a theory and the associated skill is given to the students through the practical courses. So the lab work should be adequate to complement engineering theory that is learned through the lectures. Whatever you are learning through the lectures, you have to implement it. And this laboratory should complement the theory, and it should help the students to develop competence in executing experimental work. So you can see the competence word is highlighted. So they should develop the required competency in executing the experimental work, and it aids to develop in the engineer the confidence to deal with new and unusual engineering problems. So a lab should complement the theory, should develop the competency, and also should develop the confidence to deal with the new and unusual engineering problems. So the conventional laboratory system, we use a step-by-step and carefully guided system for students to construct the circuit and to measure the particular set of parameters. So this is what we have in the conventional laboratory system. And the students, even they don't understand the reason for doing such exercises, but nevertheless will just to do what is asked to, what the teachers asked to, they will do. They will not understand for what reason it is being done. Sometimes students do not even know the basic principle of the components used in the particular experiments. Some students may fabricate false results to fit the theory, and some may copy the results from the students of previous years or from other groups of classmates. Okay. Now we have a system of open-ended laboratory system or open-ended laboratory experiments. Okay, so here, why we are moving to open-ended laboratory experiments, it is that here the student can use his or her own initiative to decide which path to follow and how to do it properly. So hence greater understanding is achieved. So you are able to get a greater understanding when you use the open-ended laboratory experiments. So the level of dependence, okay, the level of dependence and autonomy expected of the students to carry out an assessment task. So you have level 0. So in level 0, the problem, the procedure, and the methods for achieving the solutions are provided to the student. So all are given, like now how we do, everything is given, problem is given, procedure is given, methods are given. The student performs the experiment and verifies the result with the manual. This is level 0. what we are currently doing is it is at level 0. Okay. Now, first level, level 1, the problem and the procedure are provided to the students. Only 2, problem and procedure. Now, the students are given the freedom to use whatever method they want to find the solution for the problem that is given. Okay, that is level 1. The problem and procedure are provided to the students. The students can interpret the data in order to propose viable solution. Now you say what method you will use to find the solution for the problem. This is level 1. Level 2 is the problem alone is provided. So the problem alone is provided. The student is going to devise a procedure and also the method. See here, only problem is given. No procedure, no method. So the student will devise a procedure for investigating the problem, decides what data to gather, and interprets the data into proposed viable or proposable viable solutions. Now level 3 is a raw phenomenon is provided to the student. Some case study is provided or some problem you cannot exactly even define the problem. So a raw phenomena is provided to the students. The students can choose the problem, okay, develop the procedure, develop the method, and finally interpret the data in order to propose the viable solution. Everything is given to them like creativity. Just a raw phenomenon is provided. Now they have to devise the problem statement, the procedure, the method, and finally find the solution for that. So these are the levels in open-ended experiment. Level 0, where the problem, procedure, and methods are given. Only thing is they have to do the experiment and validate the result. Level 1, problem and procedure are given, method they have to devise. Level 2, problem is given, procedure and method they have to devise. Level 3, the problem, procedure, and method has to be devised by the students. So the level of independence and autonomy expected of the students to carry out an assessment task. So we have seen level 0, problem is given, ways and means, that is the procedure is given, answer is also given. Whereas in level 1, answer is not given, that is a method. It is open, so they have to find the method and also validate the result. In level 2, problem is only given, procedure should be devised, answer they should validate. Level 3, all the 3 are open. So you have to design your own problem, ways and means, and answer. So level 1, students make few decisions on whether they got the right answer. Level 2, students decide what to investigate, how to investigate, and how to interpret the result they generate. Level 3, activities are what most scientists do, because they just take up the problem, develop the procedure, find the result. Most scientists do the level 3. So levels of autonomy of laboratory activity: 0, the type of demonstration. So demonstration, it's like a demonstration where you give everything, the aim, the material, the method, the answer. The first one is like exercise, where the others are given, answer is not given. Second one, it is like a structured inquiry, where aim is given, material is given, the method and answer they have to develop. Third one, it is like an open-ended inquiry. Only the problem is given, those are open. Fourth one, it is like a project type where everything is open. They have to select or they have to decide. So this is adapted from Davies Learning and Teaching in Laboratory. Maybe I think that will be enough for you regarding open-ended. Maybe I can give you some examples. Okay. The only 3-terminal device whose all the 3 terminals can be used, okay, as input and output. Only look at these statements. So you can have like this: the only three terminal device. It's a 3-terminal device whose 3 terminals can be used both as input and output. Now you have to identify what device it is. It's a 3-terminal device. So then whether the input and the output can be used, interchange and use. Based on that, you'll have to find the device. Then now you have identified the device. Then what type of experiment you want to do, the common emitter characteristics or common base characteristics. What is that you want to do? You decide, you develop the procedure, do it and get the answer. Okay, the result of testing a diode with a bar for its cathode using analog multimeter or digital multimeter using due procedure and polarity are different. Experiment and interpret. Pick up 3 graded or equivalent transistors from a bunch. Okay, so these are some of the examples. Okay, this is regarding op-amp. Okay. Now, if you are asked to identify at what level it is, you are asked to write a C program to check whether the given number is palindrome or not. In which level will you fit this? In which level will you fit this? Level 0, level 1, level 2 or level 3? So your problem is given. You have to write a C program. So it is not level 3. What is the statement? To check, you have to write a C program. Okay. To check whether the given number. So there is a number that is given. Okay. So your problem is given.
Level 2. Huh?
Yes. Yes, sir. I'm not able to hear you.
Level 2. Level 2.
Level 2. So
Yeah.
your problem is given.
Given.
Okay. And the
materials
procedure is given. So you'll have to write a C program there. But you are not given the
syntax or anything. Syntax is given. Procedure is not given.
Yes, the method that how you
method
will.
Is how to write is not given.
Yes, so you can fit it in
level 2.
Level 2. Yes, very good, sir. Very good.
Thank you.
So design a suitable network for transfer of maximum power from the source to the load. So here explicitly it is not mentioned as maximum power transfer theorem. Okay, but you have to design to transfer maximum power from the source to the load. You have to identify it as maximum. So some clue is given from where you have to identify your problem. It is a maximum power transfer theorem, the problem, the procedure, the method. So you can say it is partially level 3. I will not say it is fully level 3 because a certain guidelines are given for understanding or give as a clue. It is given to understand the problem. Okay. So where will you fit in? Do you agree with me? Or you have some discussion? No answer. Next question. Determine the ripple factor, regulation, and efficiency of full wave rectifier. So this will fit in. So you are asked, your problem is given. Okay. Maybe it is a full wave rectifier. Your the procedure,
materials are given in the sense what is rectifier, what is ripple factor, what is
yeah.
how to
only
calculate the formulas.
Only thing the method you have to put and you have to do it. Yes. So where will you fit in?
Materials, methods. Level 2 again.
Yes, level 2 again. Here initially the motor runs in star and after a certain time it runs in delta. So here again it is a clue that is given. You can partially fit it in 3 because we need to do the experiment of a star delta starter. So the condition is given. Based on this you can arrive at It is a star delta starter experiment and you can do it. Okay. So like this, we will be able to decide what is the level you want to give. So these are the open-ended experiments. Okay, so you can decide upon giving what are the things you would like to give. Whether maybe I can go to the table. Yeah. So what is that you want to give and what is that they want to find out. So this can be decided in the open-ended experiments. Accordingly, you can frame the questions. This is to improve the competency, because students will think in what way. It is not only this way they have to do. What are the other ways and means they can do the particular experiment to get the result. So this is all about open-ended experiments. And I think finally we can move on to the quiz. Okay. Maybe I should close this and then come there, I think. Oh, as shared window is closed. So you can all join for the quiz. I have to share my screen. 1 minute. You're able to see the screen now?
We can see the screen.
Where is the link,
Yes?
ma'am?
No?
Where is the link, ma'am?
I'll post the link.
Okay, okay.
The chat, I'm posting it. You're able to see the link. Now the screen is visible. You are able to see the code 73379271. Good. So very good. Shall we start? 24 players ready. So 25. Very good.
1 second, 1 second.
Okay, sir. I think now joining a stop, so we can start. 30. Very good. Very good number. Shall I start now?
Madam, start.
Yes. I pressed enter twice. Automated unconscious mastery of activity and related skills falls under which level in the Dewey's taxonomy or the Dewey's theory? So we have seen the level: imitation, manipulation, precision. So this automated unconscious mastery of activity and related skills falls under which level in the Dewey's taxonomy or the Dewey psychomotor in the theory related to psychomotor domain? Very good. We have 13 right answers. Naturalization, the top level: imitation, manipulation, precision, articulation, naturalization. So the fifth, that is the last level, naturalization. Very good. We have 13 right answers. Let us look into the scoreboard. Oh, we have Madhukar. Very good. Fastest to answer, followed by Umesha, Meghna, Girish, Shekhar, Kalyan, Siddhanand, Sharanappa, SAR, and Seema. Very good. Very good. Now moving on to the second question. So Raju is performing a lab activity. The learning domain he is associated with is. He's doing the lab activity. So what domain he is associated with, or what his learning domain he's associated with is. Very good. I'm able to see answers coming so fast. Very good. It's a psychomotor, psycho brain associated with the hand, psychomotor. Oh, I've not given the right answer. 1 minute. I'll go back. I've not given the right answer. Okay, it's a psychomotor. So we have 20 right answers. Now let us look into the scoreboard. Now Meghna, very good. Meghna has become the leader of the scoreboard, followed by Madhukar, Umesha, Girish, Dr. Shekhar, Siddhanand, Sharanappa, GSK. Very good. Fastest to answer. Reshmi and Earthman. Earthman, you have not changed your name, I think so. Yes. Moving on to the third question. The ability to develop a lifestyle based on the preferred value system is. So finally, you become that itself. It is the affective domain. Rathwall's taxonomy: receiving, responding, valuing, organizing, and characterizing. So here it is the final step where you become that. So ability to develop a lifestyle based on the preferred value system is. Very good, very good. Characterizing, very good. So we have 23 right answers. Excellent. Very good. We have now Girish leading the scoreboard, followed by Madhukar, Umesha, Siddhanand, Segar, Meghna, Sharanappa, Darshan, GSK, and SAR. Very good. Fastest to answer this question. Very good. Moving to the fourth question. Attitudes, values, and interests are reflected by which domain? Attitudes, values, and interest, feelings, all these are reflected by. Thirty-seven have answered. Still it is waiting for answers. Sorry. Okay. So what domain I should give now? Very good. We have 17 right answers. Affective domain. Okay, attitudes, values, and interests. So now we have Madhukar, fastest to answer and leading the scoreboard, followed by Girish, Umesha, Shekhar, Siddhanand, Meghna, Saranappa, Darshan, Hari Prasad, and Hemant Kumar. Now moving on to the last question. The lowest level of learning in affective domain is. The lowest level in affective domain. So now you have learned the 3 domains: cognitive, psychomotor, and affective. So in the affective domain, what is the lowest level? Very good, very good. Receiving. Very good. 25 right answers. Amazing. Very good. Yes, very good. Finally, we have Madhukar leading the scoreboard. Very good. Congratulations, Dr. Madhukar. Followed by Girish, Mesha, Dr. Shekhar, Meghna, Dr. Siddhanand, Sarnappa, Darshan, Hari Prasad. Very good. Fastest to answer. And Hemant Kumar. So congratulations to Dr. Madhukar, who has been constantly leading. And finally, the morning also, he was the leader of the scoreboard. And now, congratulations. And congratulations to all the participants who very actively participate. Really, I was very much amazed to see the way in which you are answering. So quick and so fast. Very good.
Thank you.
Congratulations.
Thank you.
Yeah, thank you for all your active listening. I think with this, we can conclude our today's session, where we have discussed a lot regarding starting from teaching as teachers, the teaching, the learning, the theories related to that, and the type of learning styles, and the Bloom's taxonomy, which paves a very important role in the teaching learning process, and the classroom activities you can always classify, and the learning domains you can classify based upon the revised Bloom's taxonomy. And in the afternoon, we have also discussed about the lab evaluation, where we are focusing more on the procedure. No, it should be like more towards developing the competency. And finally, we have concluded with open-ended experiments, where in level 0, you give everything, ask them to complete the experiment. Then you limit the method, you limit the procedure, and sometimes even a few clues can be given where they can identify the problem, and then identify the procedure, the ways and means, and also the results. So that is the open-ended experiments, which will really help us to develop the competency in the students. So this is what we have been talking through this day. I hope you would have got a useful learning experience out of my classes and what I have shared. I really thank the organizers, and particularly Dr. Abhishek, for giving me this opportunity to share my experience with you teachers. Thank you. Thank you so much.
Madam, thank you very much. Thanks for spending the whole day with us. Actually, it's really nice actually, because a lot of patients should be there to handle the full 1 day session. But we have learned many things from you in today's session, especially with respect to laboratory and teaching learning process. Let us see whether we can meet offline for the next activity or something like that.
Sure.
It will be very nice. Like our office will get back to you with other formalities which are required later, actually, off the line. Thank you, madam. Thank you.
Okay. Thank
Okay.
you. Thank you. See you.
Yeah.
Thank you.
Thank you, participants, and
Thank you, ma'am.
Okay, Abhishek. Thank you. Mute, Abhishek, you have muted your audio.
Yeah. Thank you very much, ma'am. We will meet tomorrow, participants. And Rathy, ma'am, I'll email you after some time.
Okay, sir. Sure, sir.
Thank you all. Bye.
Bye.